We here? Getting YouTube started. Okay. Let me get the music going too. Hopefully it doesn't stutter. I did nothing to try to fix it. Yo, Budza, thank you for the follow. Zach, thank you very much. Hello, everyone. Sorry, I'm still like getting myself together. I was completely engrossed in watching Zach's Epsilon Delta proof, so I'm like still figuring things out right now. Okay, there's some music. I think YouTube's good. The killer rabbit, yeah. Obi hate, Anders hate, Pen hate. The new emotes, thank you. I got a few more slots I gotta fill up now too. I really checked. I think I have like 6 slots. I need to think of ideas. Oh, Anders got first. Okay. Oh, and Zach, you were greatly missed for codenames, but I'm sure you had a good reason. Shit. Oh, this thing. Okay, yeah, so they said, what is the value of the constant here? Indefinite integral, but all I posted was this, so I didn't know what they were asking about, and I guess they got back to me. Budza, see you around. Thank you for asking that question, because it helped me a lot to see the answer. Good luck with your Epsilon Delta ing. It's a thing they're trying to integrate. Okay. We can integrate this for sure. We got to do power rule with integrals, which I remember I did like integrate this just to see what it would look like, and I accidentally did the power rule wrong. So let's make sure I don't mess that up again. So that's like t to the negative 2/3, and when you integrate, you add 1 to the power, so you get t to the positive 1/3, and then you divide by that new power, so you multiply by 3. Ipsum, how's it going? Hello to you too. You know what? And just to be extra careful, let's go to Wolfram, because I feel like this is the type of stupid mistake that I would make. So, and it takes about 2 seconds to enter it in. So I'm guessing 9/2. Okay, good. Keyword to t. Good. Thanks for letting me know. 2 plus 2/3. You know, you're not alone. This other person asked if it was a plus. Yeah, the little crossbar and the t. I mean, I'm assuming it's a t. Writing as 2 plus 2/3 just feels weird to me, and the 2/3 is kind of small, so I'm assuming it's a t. So since this person's presumably only just learning to integrate things, oh yeah, Jed was saying that too. By rewriting this as 3/2 times t to the minus 1/3. And I think this will make it a lot clearer what's actually happening. Wait, no, wait, was it 3/3? Okay, it was 2/3. Good. Jed thinks it was a plus. It was a plus because of axiom number 1. Jed is always right. Okay. I'm just gonna give him the answer. Why the heck not? Because I like their handwriting. That's all the reason that I need. Like, look, like they did make their 2 like different each time, but they have nice handwriting, so it's enough for me. Now we can use the power rule to integrate. We add 1 to the exponent, and then divide. No. Wait. Yeah, divide by the new exponent. Wait. Oh yeah, and we're dividing by 1/3. Okay, there we go. And that's why we end up multiplying by 3. Negative 2/3 plus 1 is equal to 1/3. So we end up with 3/2 times 1/1. Is that a? It's kind of a confusing way to represent it, but we'll simplify it. Plus c. It's equal to 9/2 t to the 1/3. Let me keep doing parentheses here for the fraction, just be very clear about t not being in the denominator. Hopefully, plus c. That's what you're asking, Ipsum. The answer is, I was actually just about to type that part out. We physically can't, or we don't have enough information to know what c is with the information we've been provided. Oh my god, Anders. What is this? Prime factorization of 1 to the 1 plus 1 plus 1 plus 1 to the 1 plus 1 plus 1. Okay, so that's 1 plus 8 plus 3 to the 4th is 81. So what did I say? 1 plus 8 plus 81 is 90. And the prime factorization of 90 is 2, 3 squared, and 5? Is there, I don't know if there's a trick for that, but... Great. Hey! Is there like a shortcut there? Or were you just like giving it to me in that way to make it more painful, which I wouldn't blame you for. If, for example, we were given that, let's just like a pretty normal point to give, it's like y of 0 equals 1, then we can, actually let me do this on a new paragraph. We love some number theory on this channel. You guys can love number theory on this channel. I'm not gonna. Yeah, I'm trying to figure out what that is, SPQ. Oh, okay. Say 1. Oh no, it's I might. No, this will be fine. 9/2, and then 0 to the 1/3 plus c. It's us number theorists getting rowdy. Oh god. You're so rowdy. Yeah. You guys with your ring theory, number theory. It's enough of a stretch for me to do like the real analysis class. If there was an algebra class on Twitch, I don't think I'd be able to. I don't think I'd even attempt that. Sucking it up. And so here, what, we just get c equals 1? Oh, complex, I absolutely would. For algebra, I might try to like lurk if there was legitimately an algebra class, but I probably wouldn't be too involved in that. Complex analysis, I am like very interested in. You promise not very many matrices. I would not. I unironically would not mind matrices. The only part, well, linear algebra can be a little bit tedious, but the only part that I never learned it, so I don't understand it very well, is doing all the proofs. Like the linear algebra class that I took was very computational. It was basically only computations, and I've attempted, or I've had students when I was working in tutoring center come in to me asking if I can help with linear algebra. I was like, oh yeah, sure, I got it. And then it's like all these complicated as hell proofs. You're gone in May and June to Costa Rica and visiting family? Oh, that sounds amazing. We have to go 2 months without a Penn Center stream though? What the heck? I won't say who am I going to get my Ocarina of Time from, but of course there's the races happening right now. Well, that sounds amazing. I know, I know. Oh yeah, Obi, how long of a break are you gonna take once you move? Dude, we're gonna be down to two people for like a decently long period of time, I bet. Actually, I guess you might not know how long of a break you're gonna take. Mid to late March, whenever you get your stuff back. Okay. Yeah, that's fair. Okay, I think this is enough to kind of tell this person how to do the integral. The real part of their question is what is C, and I hope I've adequately addressed why we can't get C here. All right, let's go look for a new question. Stream for your laptop, we just don't have all the fun pop-ups. Okay. Stream for your rigs to end up on the airplane cargo rather than the boating cargo. Oh yeah, like because I'm from California, but I went to college in Hawaii, and so I had to transport. Well, I didn't have to, but I did transport my desktop rig back and forth. And so what I did, I just walked into a UPS store, asked them to pack it, but not ship it. And then I took that box that they packed and made it a check-in bag. It's still very risky, but it's probably better than a boat. So, I mean, the computer that I had at the time was like a piece of junk, and I wouldn't have been like it would have been super annoying, but it's not like it was a top of the line machine or anything like that. Actually, yeah, I know. So I'm not saying it's like the best idea, but it is an idea. But I remember like that. I built a new rig after I graduated, but that rig at the time, it was like the graphics card was sagging, and I literally had a highlighter inside of it propping up the graphics card. So I think I lost the screw that I had that would keep it there. Like, it was really like you couldn't make it much worse. Long division, I assume, just from looking at the title. Oh, there's an answer though. GPU was centered by a pen. Oh my gosh. Little did I know that like it was fate for there to be a math streamer named Pen Center. Now 0 calories Pen Center light. Differential equations. Ah, that has an answer though. I gotta see. What was the question though? It's just separable. Okay, it's something that interesting. Yeah, okay. Is that G prime? It's just straight up. It's separated for you, I guess. Okay, never mind. I don't think I'm missing out that much then. Linear algebra, a matrix problem? Oh god. Let's see. Great taste, let's fill it. Okay. So oh. Deserves 3 saves. Oh god, it's on Google Drive. Is there gonna be something disgusting in this? Okay, no, it's just, well, okay, I do think it's disgusting, but it's not like what I was thinking could be disgusting. I think this is disgusting, but Google Drive links always make me nervous. The scaling clip. Yeah, I think that was probably the best clue of the night. Oh my god, Zach, and yeah, it was such a good time because Talos had it rigged up that so that we could ask evil Talos questions, and like ChatGPT would make a response and then played like the response back through Talos's mic. There are people also like, even though Talos wasn't even streaming, people were in his chat doing like sound redeems and things like that. So like Talos would be talking, we just randomly hear like a reverb fart and like all sorts of crazy stuff. It was a ton of laughs. I streamed until I was basically like falling asleep. Like I think I looking back, I actually like I nearly fell asleep on stream because I was having such a good time. I didn't want to stop. Timmy unmuted. Oh yeah, you got in there too, Ben. Which for anyone just, I think Talos right now is doing the Road to the Centurion thing. And keep talking and nobody explodes. If it wasn't at like the exact like wrong time for me to watch, I'd be watching that right now. Got just close to nodding a few times. Yeah. French 225. Yeah. Ugh. We need to get like Dan in here too. It's unfortunate that he missed out on both of them. But okay, what's happening with this one? Why do we have R's in our matrix? What values of R does this matrix have one solution? Oh, okay. They were using Kramer's rule. Which, oh yeah, you get the determinant. Oh gosh, let me... I remember generally Kramer's rule works. I don't remember the exact specifics, though. Because you have to take like 3 different matrices that's like shifted over by 1 column each time. Something like that. You have to get a bunch of determinants and it's obnoxious, but you can do it. Or not shifted, I guess you take the answer column and you like rotate it through. Yeah, okay. And if it has one solution, what does that mean for the determinant? I think it means the determinant isn't 0. Oh gosh. Matrix number of solutions determinants. Determinants are weird. They have so many different interpretations, it seems, depending on the context you're working in. Like, the determinant itself doesn't mean that much, but it means everything if you're working in a certain context, I feel like. Determinant 0, implementing or no solutions. Okay, yeah, so we just need the determinant to not be 0. Okay. Can you do this? Just the good old-fashioned augmented matrix? I wonder if you get too many cancellations. Probably, yeah, you probably not. No, yeah, it's probably a Kramer's rule thing. Oh, I guess maybe they tried? What's this? Wait, what's happening here? Are they doing Kramer's rule or not? Oh, because doing row operations doesn't affect the determinant. Okay, that makes sense. It's still the same system, just looks a bit different. Well, they're not tracking their last column. Is that going to mess up their x1s and x2s? If you multiply row or switch. Ooh, okay. Oh, that makes sense, yeah, because the determinants, like, if with a constant multiple, the determinants also scale, I think. Something like that, adding multiple should be fine. Okay, in this case, they just do subtraction. Well, they did something before where they didn't show their work for it. Why is it 2 plus r? Why? How is this 2 plus r, but all the other row values are unaffected? Okay. So even if I definitely don't get this set up here. But if we were to go back to what they did, like, you could get like this lower left corner to be zeros. Could you though? Swap the 1 up and do some subtraction? Easy to use the determinant. The 3x3 weave method? Oh god. What's that? Oh, I don't think I was ever taught this. Love me a good weave. Oh, but one column matrix to the right of the... does it even matter what columns you use? That's so weird. So you need it to be a... Ooh. You have to repeat C1 and C2? Okay. Add the diagonal products going left to right. 1, 5, -4, -3, -1, -2, 4, 2, 3. Wow, what the heck? Now take the negative sum of the diagonal products going right to left. Negative 3, 2, wow. Then you add, well, that's all it takes? Wow. That's pretty neat. You need for, oh yeah, cross products. I feel like I would get mixed up with the IJs and Ks. Actually, I probably just would need to see it. Okay, so has someone else already beat me to the punch here? No? Okay. Doesn't work for higher dimensions? Oh. Okay, I kind of want to just see if I can work out the problem using the basket weave thing that we just went over. I don't know if I'm going to tell the person about that, or I'm not going. I don't know if I'm going to like try and like. If the person doesn't know the basket weave method, it's probably not the most helpful thing to show them. Like, unless it depends on their class, I guess. But I kind of want to just for my own learning see what's up with this. So does the why doesn't the answer column matter? Because I think we because like always that for the 3x3 matrix. We just so I assume we're ignoring this last column for reasons I don't quite understand, but we could do the basket weave just on that and see what comes out. Okay, so we're gonna need a cubic. Okay. We determine the type of solutions we get? Oh, okay. So basket weave, do our R's. +1 +1 minus I wish I drew this a bit more symmetric, but it's cool. Like that, I want to say. R cubed minus 3R plus 2. Oh, that's not a fun cubic. To column matters, we have to deal with it separately, determine a 0 when the solution cannot be unique. R equals 1 is the solution? Ah, okay. I forgot about the good old eyeball method to factor cubics. Determine a 0 when the solution cannot be unique, but we can get 0 if many solutions depending on the last column. Okay. Yeah, the question was what value of R gets us one unique solution, I believe. Yeah, okay, that's a good thing. R equals 1 works, which means R minus 1 is the factor. I wish I had synthetic division memorized, but I just don't. I have to Google it every time, and I'm too lazy to actually Google it. So that's going to be R squared, R cubed minus R squared. It's positive R squared minus 3R. R plus R squared minus R minus 2R plus 2. Looks like it's going to work out. Okay, good. That means I didn't do something horribly wrong. That is, we want +2 and -1. Wait, oh, we get r-1 twice. That's funny. Okay. Now for the interpretation bit. So they said they got r equals 0, 1. The solution should be r equals 1, -2. That's what I get. So if r equals 1, r equals -2, we have no solution or infinite. So if the question is what values of r does matrix have one solution, it's any other value of r. Right? Okay, and yeah, that's the format that they have it. Okay. Okay. I think if he'll come, I mean, oh shoot. They were using Kramer's rule though, and we did this. Kramer's rule, like that. Oh yeah, that gets you the actual like solutions to the system. That's right. Yeah, that's a good thing to start with. Oh wait, they'd say C1 becomes C1 plus C2 plus C3. That still doesn't track though. Oh wait, does it track? Oh wait, they're adding columns. Or Kramer's rule? Oh wait, no, you're not supposed to add columns. I don't know what I'm talking about. Oh, but shouldn't that be 0? Or no? R0R. No, I'm still confused. The solution vector, yeah, so, oops, what? No, stop it. Okay. They do that here for x1. I don't know where the... It's like, you know, for x1, this application of Kramer's rule, I guess is right if we're allowed to do the elementary row operations. Well... I guess. You can do column operations too? Really? Okay. So where's the error? I didn't know column operations were a thing, I'm going to be honest. Huh. Try to compute determinants and like, oh, what if x1 plus x2 equals 0? I think they're trying... Well, I think that's basically equating the solutions, like trying to show that they're linearly dependent. If I'm not talking completely out of my ass, which very well might be. I guess x1 and x2 are the coefficients though, aren't they? denominator not to be 0. Oh! For a unique solution. Because it's okay if x1 equals 0, I guess, as long as it's defined? Is that the logic here? Cramer's rule only works if the determinant is not equal to 0. Oh gosh. So I do see we do get the same cubic there. Oh, okay, so they actually could have saved themselves some work, I guess. And so Cramer's rule only works if there's a unique solution. I guess that would make sense because you're dividing by the determinant. It's a problem on Reddit, Anders. Okay. I think I get it now. So Cramer's rule, it's only valid if the thing that you're dividing by, of course, isn't 0. And I think your numbers are correct, but the interpretation / strategy is a little off. Cramer's rule, wait, no, with a C. Only valid if, how do they, okay, A is not equal to 0. Permit? Okay. Jerry's rule? Yeah, I was thinking like Seinfeld. The main thing to pay attention to. It seems like you already found. It seems like you found that A equals R cubed plus minus 3R plus 2. Plus 2. We need to set that equal to 0 to find where, not Cramer's rule. Well, yeah, defined where, I guess, yeah, Cramer's rule is italics not valid, and we can take any value besides those. Okay. I think that's sufficient here. Thank you guys for your help with that. I do better about giving out saves. I feel like I always forget when people actually like help me out. All right. Grade 12. Oh, I was doing linear algebra. I missed out on doing a calculus question. Yeah, there's already 2 answers, so. Ruche Capelli? Sure, I butchered that. What is that? The rank of its coefficient matrix and that of its augmented matrix are equal. Oh. I mean, okay, my linear algebra is really rusty, but to get the rank of a matrix, don't you have to basically get it in reduced row echelon form anyway. Because it's like the rank is the number of unique rows. Or, you know, linearly independent. I might be getting my terms mixed up though. Not the full reduction. Oh, okay. So I'm gonna say like if it requires you to like basically solve it anyway, I don't know if it's helpful in this context, but I also don't understand this, so. Is he trolling us, or is there a way to solve for x? I just want to see what this is. Oh god, we got some ambiguous parentheses here. I assume there's supposed to be parentheses. Oh, wait, yeah, what the hell is this? I guess a change of base does look appropriate here. Yeah. I hate the lack of parentheses. This does look like a kind of a fun problem, though. Can you do everything to the power of 10 here? Oh no, Anders. All right, let me look at that first. 9 to the 0 plus 8 to the 1 plus 7 to the 2 plus 6 to the 3 plus 5 to the 4. Okay, 1 plus 8 is 9. Plus 49 is 58. Plus... Oh my god, 30... What's 6 cubed? 36 times 6, 196. That it sounds right, but I should actually like calculate it, right? No, it's 216. 36 times 6. You get 6, carry the 3. 18 plus 3 is 21, 216. Okay, so we have 58 plus 216. Oh my god. 58 plus 216 is 58 plus 216. 224 plus 50 is 274 plus 5 to the 4. 5 to the 4 is 625. What number did I just say though? 625 plus something. I said 274. So 274 plus 625. Technically, I think this breaks the rules, but I'm doing it anyway. 625 plus 274. 899? I actually did that right? Oh my god. I can't believe I actually did that right. $899 feels like a very like clean number. Like it's you can somehow prove that's equal to 900 minus 1 or something like that. Weeknight Gamer, thank you for the follow. Using log base 3. Huh. That is all. I kind of want to investigate this problem just for fun. See if we can work it out. Because I do have two conflicting answers there. Someone's saying you can't solve it People saying you can with a more clever change of base. Let's see if we can work it out for ourselves. Oh god, okay. You're getting sprayed. Bad whiteboard. Okay. So we have log base 3. I'm going to assume some parentheses here. Of x plus 2 is equal to log base x plus 3 of 9? 9? Okay. So I guess we'll do a change of base on both sides here. Well, that It's already in base 3. I guess we want all the logs on the same base here. So let's do a change of base on the right side and leave the left side alone. So log base 3 of 9 over log base 3 of x plus 3. Bring that over there because it looks nicer. That's 2. So I don't think we have an identity for 2 logs multiplied together. If we do 3 to the power of each side, what happens there? We would get x plus 2 to the log base 3 of x plus 2, do we not? Sorry, should be a 3. I don't like this. I mean, oh, and I didn't even do 3 to the power of the right side, did I? I don't know if this is possible. Like, no, I don't see how you do it. Hey, Viv. I'd like to remind you of the first line in my bio. There's a problem I can't not solve. If you give me a problem, I guarantee you I can walk away from it, okay? That's what I'm saying there. Welcome in, Weeknight Gamer. So I assume we get this. I assume that Wolfram won't be able to solve this either. Let's just see what it says though. So what? And I tried just like manually plugging in like 7 for x. Are there any other numbers that might give me, like, if we did 0? No. 1? No. Yeah, I don't know what it'll be. Oh, wait, can you make it like a system? Oh, thanks for the exact result there, Wolfram. Okay, it does get a numerical solution. Like, okay, I assume this isn't going to help, but just for the sake of curiosity here, what if I looked at only log base 3 of x plus 2 and said it's equal to something y, let's say, and I convert this into exponent form and get 3 to the y equals x plus 2, and I do the same thing for the other part of the problem, equals z, and I then say x plus 3 to the z equals 9. Does that help us? That would mean I don't know if this, I might be completely off my rocker here. 3 to the y plus 1 is equal to x plus 3. What if we plug that in here? There's no way this helps, right? Wolfram could have just brute forced it. We want an exact solution, Viv. Wolfram Apple does brute force it to get like 2.2 something. But that's not, you know, that's engineering. It's not math. What if... Okay, this is probably even worse. What if I took that and I subtracted this? No, no, no. No, I don't see how you solve this if there is an analytical solution, if that's the right word. Yeah. This doesn't seem to be possible to me. Okay. Closed form, that's the proper thing. It has dead spots where the coding has gone weak? Oh. Honestly, that's something I ever even considered. I bought it off Craigslist, so I completely believe that. Like, if I look at it visually, like, there's definitely bumps, but the coding seems the same. I don't know if there's an easy way to tell, but I never actually owned a whiteboard for myself before, I don't think, so. But yeah, it was just a $25, like, used whiteboard. Met a dude in a mall parking lot, basically. Assuming screen has unimproved and may do it. Oh, okay. Yeah, I mean, people spray all sorts of random garbage on their boards, so. That's not it. AP teachers gave us this for homework. I guess it's a troll, I don't know. But yeah, no, like I looked at buying a whiteboard new. They're very expensive though. So, Oh god, another Google Drive link. All right, we're good. I don't like that they're using Google Drive. It makes me nervous. If I was being really security minded, I just wouldn't click on it at all, I guess. But I mean, it doesn't really download it. I don't really know. I feel like it's generally not usually a good idea to clone random Google Drive links on the internet, but I did it, so. What's happening here? The logarithm one? Yeah, to be fair, it's an AP class. But, I mean, I don't know if there is a closed form solution. Oh, you mean for this matrix one? Did they say they're in high school? Linear algebra. Oh, grade 11 to 12, or essentially A levels. For A levels, it'll make sense. Grade 11 to 12, they. I mean, I don't know when you do your A levels, I guess. So they apparently understood what I said. But the thing that they said equal to 0 was not what I said we should set equal to 0. Get a quart of whiteboard paint and tools for 85 pounds. I was gonna guess pens, which would be really cheap, I think, but you know, when I was looking into whiteboard like solutions, I saw that whiteboard paint even exists, which I never heard of it, but I guess I could have bought like a sheet of plywood or whatever and just painted it, but I don't know. Yeah, no worries. To be honest, the actual symbol for pounds I get mixed up with euros, because I know euros look like an E, but when I actually see pounds out in the wild, it looks like an E to me too. So I always have to think about it. Oh, you're on Linux. Okay. Glass whiteboards in almost all the meeting rooms. Oh, interesting. Back when I had an office job, the cubes were like, or the cubicles were like the highest like 2 feet, I guess, were like foggy glass that you could write on like their whiteboard. And then the actual meeting rooms, they'd have just normal whiteboards, I think. $10 at your local hardware store? Oh, that's kind of funny. The bot that allows a command. Stand down, bot. So I'm not going to show it because it's saying, I mean, I don't think saying the city you live in is that important, but I figure I shouldn't like publicize it that much. It's 11 bucks for me too, I guess. And it's at Lowe's. Really? How big is it? It's about the same size as mine. Wow, I never checked Lowe's. The Lowe's that was by closest to me closed down. Oh, no frame, no trim. All right, see you around, Viv. I think Home Depot, I do remember checking Home Depot, and I think there's a similar thing. Maybe it was a bit more expensive, but I think I just wanted an actual whiteboard. I don't know, that might be a better solution though. Like I've been thinking about an easel, because it'd be nice to be able to like stand up when I switch over to the whiteboard. That has a couple of issues that I have to figure out though. But yeah, Viv, hope you have a good Saturday. Thanks for being here. Students use the regular Windows for class this semester. Stephen got so bothered they... Oh, whiteboard markers on the windows? Okay. Yeah, that could get... I mean, I bet the sun would, like, bake in the ink. See, I'm not saying that an easel is going to be all that expensive. Supports 5 pounds. Take that, bot. I think, oh man, there's some issue that I was thinking that I might have with an easel, but the thing oh shoot, I should charge my phone. Not running out of juice today, little buddy. Okay. I have to make sure it's actually 5 pounds. I don't think it'll be much heavier than 5 pounds, but currently my phone is on a flexible arm attached to a chair, which definitely won't get high enough for an easel if I want to stand up. So what I kind of want to do is rotate, like have the whiteboard like to the side of my desk, and I'll just like get up from my chair and go over to it. It'll be a completely different camera angle. That's what I've been thinking about. I need to get an actual tripod that's high enough for that though. And I don't remember, with an easel, I guess there's no issue with an easel besides that. Which, a tripod for an iPhone is incredibly cheap, so that's not really a big deal. I was just hoping to like hold out until I could get an actual camera, which is kind of a stretch, but I just didn't want to buy like another like plastic piece of junk off Amazon if I could help it. But I might just do it because the camera shaking, like when I go to watch back my VODs, I cannot deal with the camera shaking. I'm surprised that anyone watches me. So I made it a lot less shaky, but I still sometimes shake it by accident. Let's see what's up with that, Jed. And, well, that's how my stream used to be, Jed, before I was affiliate. Even for a while after I was affiliate. I never showed my face in a pencil and paper on my desk. Which, honestly, it is kind of a vibe, and I could do a face cam with that. But I just like the feel of a whiteboard. Small whiteboard dry erase. I'll do that with a downward facing camera. Yeah. I'm going for the whiteboard things. I just like the feel of the whiteboard. But if I wasn't using whiteboard, I would have a downward facing camera and just like have my hands like I used to. So they said they understand it, and they didn't write it right, so I don't get what their misunderstanding is. What's happening here? They multiply row 2 by 1 over r minus 1? That seems dangerous. Oh, I erased my work. Are you limiting r equals 1 as a potential thing? You went to NCTM back in 2012 and got one of these for free. And sorry, I'm just blanking out my browser here because I just don't the website to save my zip code. This one doesn't seem like it does that though. For 11 bucks. Oh yeah, it's a pretty small one. I mean, I'm pretty happy with my current, like the whiteboard itself. It can be a little pain to erase it, I guess, but no, Jed, they use the IP address. I would need a VPN to actually fix that. I mean, the IP address isn't perfect, but it still gets pretty close, so. That's why I switched to using Opera, and then Opera's VPN turned out to be pretty horrible, so I'm just using it without a VPN. And I'll pay for a VPN if the stream becomes big enough to sustain that. Go to the Chiseled Expo. Oh, okay. Brave? Oh, Brave does have a browser, don't they? I mean, that might be a good shout. The automatic graph thing would be pretty nice, Obi. I'm making a notepad right now for things that I have to do today that I almost certainly won't do, but I'll try to remember to do them. I still need to look up mods for Tabletop Simulator, because hopefully me and Bob are going to do our Tabletop Simulator stream next Saturday. But I need to find some good mods for us to do. I have a start. I have a few leads. I just need to like look into them. And hopefully I'm gonna find a bunch of games that are like good for like higher numbers of player too, so we can get like a group session going too. Codenames is good. I mean, I like the browser version because like people on Linux don't have to worry about compatibility. Because I know Zach is also on Linux. I didn't know that you were, but I started off with like we should as a group do code names because it's free and it's browser based, so it's pretty like approachable. Here's another idea: use a clear acrylic sheet, a grease pen. And then on the front is where I'd make the graph. Use a proton. Oh, okay. Yeah, that's something. I mean, I guess I'll make a note of that too on my to-do list that I'll probably get through in like 2 months. But having some kind of pre-made graph might be handy in some form. Okay. Overhead sheets, put them inside paper protectors. Wet erase on the sleeves. Ooh, that's smart. And yeah, the overhead projector sheets is where my head was going to. So I remember having my teachers use those as a kid. Kind of like you say, just like their hands super like blown up too. Yeah. I haven't thought about that in a long time. So it looks like they're trying to force this to be, well, I guess not reduced row echelon, but like reduced whatever when you only have the lower left corner as zeros. So they try to find where k squared, or it looks like k's, but they're r's. R squared plus r minus 2. Oh, you get the same roots, but with the quadratic. Wait, what's happening here? Oh my gosh, I don't think I understand this either. So they somehow conclude that we need R1 minus R times R3? This is I feel like the teacher got a little lazy with their handwriting here, and it's really impacting like my ability to understand what's happening in this solution. Maybe it's just me though. It seems like they want this quadratic to be equal to 1. Or, oh, they're taking just that. I see, they're dividing each side just of that last row. They're basically scaling by 1 over r plus 2 times r minus 1. Okay. So let's understand how they get to this as their r3, but this isn't written in a very clear way, I feel like, but regardless. Why are we interested in this? AV services in college, people of color seeing mounted LCD projectors overhead. No, yeah. Yeah, my school had those too. Teachers hardly ever used them though. Or at least we started to have them. They also like towards the end, or like, I'm talking about like K through 8. So like towards the 8th grade, they started to get the smart boards with like the fake markers that you draw on. I mean, they're still like it's like there's a projector pointing right at the touch screen, I guess, because you didn't have an actual touch screen that big back then. And then you have the fake pen that I guess can still sense the touch and it will draw it on for you. Dude, I wonder, I guess classrooms must be kind of crazy now with you can have an actual just like giant iPad up there. Oh yeah, as long as that peels off nicely because I'm a renter. That's like a nice. Oh. Yeah, that would eliminate the need for an easel. Cause yeah, one of the things that was stopping me from, or one thing that kind of forced me to have the whiteboard just on 2 chairs like it is currently is I tried to mount it on the board, or tried to mount my board on the wall in a renter like friendly way without like drilling into the wall. And it was a whole day. I ended up getting myself a pretty bad cut on my finger just because I was being clumsy. 3M? I was trying to use those like adhesive like command strips. I found some like beefy ones that apparently could theoretically hold the weight. The problem was the surface of the whiteboard, the adhesive doesn't really work on it. And the frame makes the so my issue was the frame made it was too hard to get the strips on the back of the whiteboard because the frame is too thick. Like, it creates that like lip. So I couldn't put the strips just like in the middle. And the frame is, the lip is too thin to put the strips on the frame. So I tried, okay, well, let's take off the frame. But that exposes a lot of sharp edges, as it turns out. And it was just not a good idea with the whiteboard that I have. So that like adhesive thing that just sticks on the wall might be a good shout. But I don't really want to buy another whiteboard. I just want to make this one work, I think. So I'm probably just gonna go for an easel. All right, I want to see if I can figure out this explanation, but I'll look at this link too. Yeah, I didn't have that exact one, but I had basically that thing. It doesn't work with the whiteboard that I currently have. And the frame kind of messes everything up, and the frame is kind of necessary. All right. Why are we taking x1 plus x2? Make sure that no one else has replied in the meantime. So, I mean, it's still the same thing where we're looking at where the denominator is invalid. Just, I guess, in a different way. I really don't know where this thing comes from. Taking x1 plus x2, investigating what that equals. K I'm looking at this thing in the black box with 110. I don't understand why x1 plus x2 equals 0. Both the student and the teacher have it, so I assume it means something, but I don't know why that's of interest. Oh. Yeah, I didn't spot that. All right, thank you. Wait, r equals 0 and 2. Wait, they edited their post. It used to be r not equals 0 to, I think. I just refreshed. If your tab is old, it might be on your end. Have one solution and x1 plus x2 not equal to 0. Or equals 0. Oh. Yes, Jed. Yeah. Or like they're asking why the solution they got is wrong. Well, I also didn't read the whole problem, evidently, so we're in the same boat. So they get k can't equal R, that looks like a K, dude. I hate that they draw they write their R's like that. It looks like a K. R doesn't equal 1, negative 2. Which is what we get. So it's the thing that that's going to be an X3, Jed. I read that off as a typo. Oh, you know what they're doing? Oh, they're taking R1 over here, subtracting R times R3 here for some strange reason. Oh, to make it match this. This work down here is not... It builds into this row in the middle. It's not... Okay. Ah! Oh my god, I feel like I'm... I like a... This is the Da Vinci Code or some hard like enigma that you have to like unravel. I think this row here is the interesting bit, and this thing that's below, which I would think logically would come after this row, actually builds into that one in the middle. So or does it? Oh my god, I hate this. I hate linear algebra. I can see how 1, 1, 0 is the same thing as x1 plus x2. And we need this thing to be equal to 0. But how do they know that x1 plus x2 is equal to r minus 2 over r plus 2 times r minus 1? Like, I'm trying to figure out where this comes from now. Common denominator of what, though? R and r over r minus 1? It seems like R3 is involved here, but I don't get why if this is x1 and x2. I guess x1 and x2 are involved. Oh my god, I don't know. Well, yeah, but why the extra R? Can we maybe just, is there an easy route to helping this person out and finding an algebra error that they made somewhere? Because I think they understand what, like, how to solve this problem. They just, that's what it sounds like, but they get 0, 1, and they should be getting 0, 2. Like, maybe should I be focusing more on this? What their work was? Well, but why that extra R, Jeff? That's like, or why is this extra R here? Or which is the same as that extra R there? All right, sounds good, Jed. So they're trying to do Kramer's rule here. They take R at 0R, they plug it in for the first column. The other columns are the same here, so 1 R minus 1, 1 0 R minus 1. I'm just, for now, I'm just taking this as fact and checking their work from, I guess, the end to the beginning. And so they eliminate along the middle row, which seems smart. Okay. Plus, minus, plus, minus, plus, minus. So yeah, that is a plus in front. And if it was minus, it wouldn't change when it's equal to 0. Wait. No. It's weird because they get the right cubic here, it seems. So I feel like whatever they've done for the row or column operations seems like it's valid. But when they apply Kramer's rule to x sub 1, maybe did they mess up with x sub 2 somehow? Like, I don't see the error would be there either. Hmm. Okay, I feel like I shouldn't spend. I probably spent like half the stream on this one problem. Maybe I'll just take a little break from looking. I feel like I should be able to understand it, but I've just been looking at it for too long. Let's just do a different problem for now. It sounds like this person needs inverse Z. Well, or maybe just the empirical rules. 68, 95, 99.7. Oh, well, that doesn't apply to 90%, does it? Right, so it's not going to be one standard deviation. Oh, they don't say standard deviation, just one area under a normal distribution. So yeah, Jed. Hello, hello?
So did you plug this back into like Wolfram Alpha or anything like that?
No, I was thinking about trying it, but did you?
Yeah, here's a link for you. I'll just send it into your where do I stick this? Just put it in your DMs, I guess. See if that works for you. And that basically gets you through all the matrix operations. Just reduce it down to
Okay.
and we can work through that if that's what you want to do. I think was it Penn was doing some of these earlier yesterday, I think. But you end up with that set of equations, right? And so then if you're doing x1 plus x2 is 0, you're going to take x1 is the first the top right cell, x2 is the rightmost second row thing, and so you get the r squared minus 2r over that common denominator, and that's going to be equal to 0. And then you solve.
Okay, so yeah, from this step, that makes sense how we're going to get r equals 0 and r equals 2.
Right.
Now, why
Because r
didn't
squared
they
minus
get
2r is,
there?
yeah, so I got to go back to pick 1 now and see kind of where he went wrong.
Because they're doing some fancy column operation stuff, which I don't completely understand.
Was he adding? I mean, it looks like he got the matrix stuff set up properly. And he was looking like he was trying to get into row echelon form, but did he make it there all the way?
It doesn't seem to be drawn out. Like, ugh. They just get it to be simple enough, and then they get the determinant for the sake of Kramer's rule. I think there must be a mistake somewhere in this matrix, because they still got the right determinant, but something else must be off.
Wait, what happened to the so he originally had like this, the coefficients for x1, x2, x3 equals, r0, r. So then how did he get to a 3x3 grid and ignore the right-hand side? I guess is the question.
For Kramer's rule, at least, you start by doing just the arithmetic matrix without the answers,
Okay.
and then you sub in the answer column into like existing columns inside that 3x3.
But if you manipulate the left side without manipulating the right side, you're changing the vectors, aren't you?
That's a. It would seem like it for whatever reason Kramer's rule still works though.
Okay.
I can't explain it, but yeah, for some reason it's okay.
Okay.
So,
yeah. Let me read up on Kramer's rule here and see kind of how that's. It's been a while since I had to do that.
yeah, I mean, I guess it's weird. Maybe because. Okay, well, no, actually, maybe I'm misinterpreting what you're saying, because they're doing these operations first before applying Kramer's rule, which.
Well, Kramer's rule just seems like you're doing a lot more work.
I
Because you
mean,
basically have to do determinants of 3 different matrices, don't you?
yeah, but like, this person is clever in making it simpler.
This person who? Pick 2 or pick 1?
In pick 1, I think in pick
Okay.
2, I was trying to see if they do a similar thing, but they engineer so there's a lot of zeros, which makes getting the determinants a lot easier. I guess I'm starting by trying to verify that. I feel like when they're doing these column operations, well, I guess the column operations, if you're doing column operations, they wouldn't affect the answer column, which it feels like these things shouldn't be valid.
So what was the transformation he did to get from the matrix in the top right to the next line down?
I want to look up what column operations do, I guess, but basically they took So it took column 1, the R11, and they added the other 2 columns to that. So
Okay.
R plus 1 plus 1, 1 plus R plus 1, 1 plus 1 plus R.
Okay.
And so they all become just R plus 2.
Right.
And then they take column 2 and column 3 and each subtract column 1 from it, which you get 1 minus 2 plus R. I don't know how it stays as 1.
Well, it looks like they kept columns 2 and 3 alone. They didn't change columns 2 and 3.
Oh,
They
right,
just
yeah.
changed column 1.
In that first step, yeah.
Okay.
I was moving on to like the next step where it seems like they're doing row operations, but they say C, which maybe that's an L or something. Okay, maybe they're doing row 2 minus row 1, which would be more consistent with what's happening with the math. And row 3 minus row 1.
Well, it looks like they created this new matrix that starts with the first column as being 2 plus R all the way down, and then took the determinant of that, roughly, or not, or they at least reduced it using row operations. But they're changing the matrix at the beginning, so you're looking at 2 different formulas. Because if you do that, I mean, aren't you basically saying that x1, it doesn't matter what x1 is because it's the same thing in all 3 equations?
I think it'd be the same thing in all 3 equations. I don't know. Maybe it's when they're doing these row operations that things get screwy.
Yeah, I'll just
Yes,
need
Matthew,
to
I don't know if
read
there's
up
a better way
on
to
Kramer's and see kind of what I'm seeing some examples on how to do it with like a 2 by with a you know two of them. But if you're doing 3, you're plugging in. Yeah, what I'm seeing on the wiki here is this kind of notation, and I don't know if this is
Hey, Cruz.
I just posted it in chat or in your DM. So if you've got that system of equations, which he had, then you can figure out the value of x, y, and z by doing that kind of operation. You have to, or in this case, x1, x2, and x3.
See, this
So
is
he's gonna have to do it 3 different times, one for each value, which seems
right.
nasty.
The issue is that they or not necessarily the issue, but the thing that's happened is they've done a bunch of row operations first to simplify getting all these determinants and make it a lot quicker. But one of those row operations must have been bad.
Yeah, I mean, they basically just said, okay, they changed one value but left everything else exactly the same. And I don't know that that's a legal step.
Yeah, so I think I'm gonna give them a general reply because I really can't figure out exactly where they went wrong, but it must have been one of the row operations, and I just don't know enough because certain row operations don't affect it, the determinant, so they're free to do whatever they want in some respects, but other ones do, and I just don't know the distinction well enough.
I mean, I wonder if there's a solution, a more elegant solution where you could say, okay, well, rx1 plus x2 plus x3 is r, and x1 plus x2 plus rx3 equals r. So if you set the 2 equal to each other, you can come up with a ratio of x1 to x3. Right?
I mean, we don't want the ratio. They have to be equal, like x1 plus x1 x. I guess we want them to be equal to 1 as a ratio. Cruz, that sounds vaguely familiar. Half adder and full adder. It's an algorithm, right?
So you got r minus 1 x1
Oh, these.
is equal to r minus 1 x3.
I might be able to remember these.
So
Do you
x1
have a question about them?
x3. Is that safe to say?
I'm sorry, can you say that again?
So if I take the first and third equations and set them equal to each other because they are, and simplify, I'm getting x1 equals x3.
Yeah, because they have the same result.
Right, they have the same result, so they have to be equal to each other. So then you plug x1 is equal to x3 into the second equation, and you get 2x1 plus rx2 equals 0. And so you have to figure out, it's like, what are your values of, again, you're dealing with x1 and x2, which are unknown. I don't know if that really gives us anything.
I'm not gonna give this. I'm done with the question, Jed. I'm sorry. I'm just gonna tell them one of their operations must have been bad, and I'm leaving it at that.
Okay, sounds good.
So yeah, sorry, and thank you for trying with it, but I'm just kind of done with this question.
All right, we move on.
It's no problem I can't not solve.
Whatever.
All right, I'll see you.
All right, bye.
So Cruz, I think I might be able to remember half adder and full adder. Because I did take a class and I do kind of remember learning about those. Like, what do you have to do with them? Or you just want me to explain them? One of your row slash column operations must have been bad at the beginning. Seems fine to me. I'm starting to get out of my depth. Maybe the row operations you did should have also affected the answer column. Okay, that's the best that I got for this person. Right, half adder, you add 2 single bits and you have 2 outputs, which are the sum, and if you, in the case of 1 plus 1, you have to carry a 1. So, Chris, if you tell me what you're trying to do with this, I can try and explain it. Oh, okay, here we go. Oh, gosh. How to get to A XOR B XOR E. A prime BE plus A BE prime. Is the prime not? So using half adders and full adders, how you make those? Prime is not, and then what's like the A prime BE? Like when the letters are just next to each other or without an operation. The faces. AB is and, okay. And plus is or, okay. That would make sense to me. Yeah, but I get it though. It's B parentheses. It's just kind of funny. Is an input carry as Cin? What would input carry be? But if you have 1 plus 1 plus 1, don't you need more than 2 bits of output? I guess not. Because you have just 1 plus 1, you get 0 sum with a carry. Okay. Yeah, I'm pretty rusty on this, but I do remember learning this. Oh, it's still addition, but it's just denoted differently? So are A, B, into E single bits? What are we XORing today? It's a question from Cruz. Um, Again with the faces, yeah. Okay, I guess I'll try to start drawing stuff out. I'm probably gonna do it wrong the first time though, just as a warning here. So, starting with the first part of the question, we want A XOR B XOR E. So exclusive OR, I guess the truth table that we want oh, it's going to be annoying to have to do it to that level, but basically it's only going to be true when exactly one of these are true and no others. 8 cases? Yeah. Oh yeah, only 8 cases because okay. I mean, yeah, it could be worse. 0 0 0, just count in binary. It's the easy way to do this. 0 1 1 1 0 0 1 0 1 1 0 1 1. Right? 1 2 3 4 5 6 7 8. Okay. This, none of them are true, so that's a 0. That 1 1 0 1 0 0 0, right? Because exactly one of these has to be true for an XOR and no others. So I think that's our expected output. Wrong? XOR, isn't it? One XOR 1 equals 0. Yeah. Oh, wait. Oh, like this one. No? I think I'm okay. The last case? Oh, wait. Oh, I see what you're saying. That one. Yeah. These first two XOR to 0, and then you get 0 and 1. Oh, that's clever. I think you're right with that, Jed. You don't really need the truth table the first one because you get A XOR B from sum, then add E. Hey, Hauke on YouTube. Yes, I'm dual streaming. So working on a circuit problem right now. I'm pretty rusty on these, but I'm trying to see if I can remember it. So yeah, that last case is sneaky. I guess if we have our 3 inputs, my instinct is just do this only with half adders because they're a bit simpler to work with. Actually, no, maybe a full adder. Can we make a full adder work here? If we only listen to 1 bit of the half adder, that's what I want to check right now. So like this case, it matches. This case, it matches. Yeah, if we only listen to the sum bit. Oh, but not the last case, it doesn't. No, last case. No, yeah. So is it just a full adder, but we ignore CL for our XOR? The first case. Well, yeah, so I was thinking either we do two half adders or 1 full adder. And actually, I guess 2 half adders is a full adder, isn't it? That's kind of in the name. So I think you could do it either way. But the truth table that I just drew on the board is the exact same as these first 4 columns here. So I think you just want a full adder and you ignore CL. What's up with that, Cruz? Let's see. We do need to make a drawing. Okay. Which we can go through as well. You're having trouble with the others? Okay. So here we're using 2 half adders, it looks like. So you have A, B. I don't remember these symbols, like with the... Shoot. Okay, how'd you solve the third roots from negative 216i? Very painfully. Wolfram Alpha could get them pretty quick. I know kind of how to do that. It will take me a pretty long time to work out, though. I'm gonna look at Cruz's problem first. If you are gonna hang out, I'll take a look at it after this. But I'm gonna work on this circuit problem first, and then I'll take a look at the third roots there. No worries, Hauke. The flat side is A and the curved. Okay. So a half adder. Oh, okay. And the half adder includes it does an XOR and then an and we're just ignoring the and we're only taking the XOR. And then we feed that XOR into the next XOR and the other input. Okay, so yeah, I think I'm on board with this. And you're having trouble with the other ones? More than this XOR, is what you're saying. So how to get A XOR B XOR E, which we just went over. And you seem to have already gotten that. Missing 1 OR? I am? Or this drawing is? You can only use half adder? Okay. If the first HA produces a carry, or the second HA produces a carry, that becomes the CL. I don't get what you're saying, Jed. If the half adder includes an XOR in its definition, I think this is okay. Hey, Bob. Yeah. See, you have to do an OR on the lower two outputs? Why? We're just ignoring those two outputs. What's wrong with that? So, Cruz clarified we're only allowed to use half adders here. So I was saying before just use a full adder, but if we're restricted to just using half adders, okay. Okay, Jed. I think that's what's happening here. So then looking at the rest of the question here, are these just cases of XOR or A prime BE or ABE prime? So use only 3 half adders. I think it's just a clue for these next ones. Okay. We use 3 half adder. And so I guess I'm still trying to wrap around what the question is asking. So for the A prime BE, like for like the second thing that you typed out, do we want a circuit that produces 1 for that exact case and no others? Is that what the question is? Like that? Okay. I guess I'm not sure what the goal is for these last 3 things that you've written. Oh, so you take the drawing you already made and you show those exact, like the actual cases and what the output would be? Oh, not that. I was trying to, I would have to go back. Because I didn't do a new tab. There. Ah, no, bad. Okay. I mean, I guess, so I think I agree with the drawing that you have here. And are you saying that you have to calculate? No, I'm sorry, Chris. I just don't get what the next part of this is asking. Because you could like blindly say like, you know, A prime and keep BE as normal, but I don't know what that accomplishes besides like if you're supposed to calculate specific cases. My nose is running, so I'm just gonna be right back and get a tissue quick. First, if there's any clarity you can give me, please do. But if not, I might go on to Hauke's question. We, the problem is how to make an OR when you only have XOR and add. Well, would your OR come from the carry bit? No. So if you were to sum together if you were to do two half adders sequentially, that would get you an OR. Where you feed the sum and the carry into another half adder. I think. Which output would you listen to though? Okay, so this might be completely off base, but if the only part of the question is or if the problem that you're having is with the plus, I think you could accomplish that. So you just have like I want to talk about like, you know, just A and B as examples here. If this is a half adder, I think you take the outputs of this half adder and feed it right into another half adder. And then you only listen to the sum. I think that will produce you an OR or a plus. But I'm not sure if I'm really interpreting. I feel like I don't understand what the goal is here. What I'm thinking is the only way you don't get a 1 in the sum is if they're both 0. So the first half adder takes care of the cases where of these like middle two cases. And the second half adder takes care of the case where of this last one. So you have to add in the carry bit to that sum and just make it into one sum bit. What I basically noticed in this chart is if you add the sum and the carry, you always get a 1 in the sum for an OR, which is what we would want. Is that true, Jed? Maybe. I'm not sure. I'm kind of rusty on my circuits. So yeah, I'm sorry, Cruz. I feel like I'm kind of not well versed enough in this to give you a very firm answer here. Completely wrong? Okay. It's equivalent to... Oh, okay. Some kind of weird De Morgans. Okay, I guess that's maybe a more elegant way to say it, because I feel like I stopped understanding what it is, but... Okay. I'm going to look at Halke's thing. So I can't make any promises here either, unfortunately, but I've done these problems like once or twice before, and I kind of remember what the technique is. Okay, and so that makes more sense to me if you can like factor things out and get it in a more basic format, I guess, because trying to do each operation manually seems like a huge pain. So you want the third roots from minus 216i. So you set up the equation z cubed equals minus 216i. And I'm trying to remember how you do this. You take z equals re to the I theta. So you get re to the I theta cubed equals, just say minus 216i. So r cubed e to the I 3 theta minus 216i. And there's something, now comes the trick. I think we need to get that into exponential form too. So minus 216i is like way down there. So the radius is 216, and the e, or the angle is 3 pi over 2. So potentially many angles there, I guess. 3 pi over 2 plus 2 pi k. Actually, I think this might just be it. Because now you say r cubed equals 216. That feels like a perfect cube. I can't think of what it is off the top of my head, though. Is it 8? No, it's not 8. Oh, wait, it's 6, right? I worked this out earlier. And then you get 3 theta is equal to 3 pi over 2 plus 2 pi k. And k is an integer here. I think even negatives. Yeah. So you divide everything by 3 and you get pi over 2 plus 2 pi over 3k. Is that actually the answer? Third roots from minus 216i in trig and algebraic representation. Okay, I hope you're still here. If you did have to leave, I understand, but I feel bad if I didn't get a chance to answer your question while you were still here. So I think we'd have to take cases. Let me make sure that I'm right so far before I get too crazy. We expect only 3 roots, don't we? So oh, you are still here. Okay. For a third root, we expect 3 answers, and Anders, I'll look at that after this, just so I'm on my train of thought. And how to figure out what 3 cases we want? I'm trying to remember that. And thank you very much, Jed and SPQ, for helping with that. Roots of complex numbers. So let me get to the bottom of this one, and then we'll go back to that circuit problem. Oh, that's right. It's not all k's. It's k's from 0 up to n minus 1. So we want k equals 0, 1, 2, 3. That's the thing that I forgot here. Got the answer as well. You don't really know how to get there. Okay. I hope this makes sense to you so far. I'm not doing a good job of explaining it because I'm not the most familiar with this for myself. Zero, 1, 2, because we want the third root. And so now we need to figure out what all of our thetas are. So theta equals, for k equals 0, we get pi over 2. And if you have a question, please let me know. For k equals 1, we need a common denominator. So we get 3 plus 4 is 7 pi over 6. For k equals 2, we need another common denominator. 3 plus 8 is 11 pi over 6. Okay, so our answer's in exponential form, which isn't what you asked, but we need it here first before we can do anything else. Our 6e to the I pi over 2, 6e to the 7 pi over 6, I think. I'm going to verify this in Wolfram after. 6e to the 11 pi over 6. Oh, really? Anders? Okay. That's a nice little fact that I didn't know. And so you said you want them in algebraic and trig form. Okay. So I think the trig form is a bit easier because these translate with many fewer calculations. This first one becomes 6 times cosine pi over 2 plus I sine pi over 2. And actually, these will build into the algebraic representations too. Cosine pi over 2. Oh, sorry, 7 pi over 6. Well, that's not unit circle though, is it? And then finally, 6 cosine 11 pi over 6 plus, oh my god, I sine 11 pi over 6. Okay, so that's the trig form. And then to convert it into algebraic or rectangular, I don't remember what they're actually called. I mean, for that one, we can just evaluate pi over 2. Cosine of pi over 2 is 0. Sine of pi over 2 is 1. So that one becomes just 6i. 7 pi over 6, I don't think that's unit circle. So you'd have to maybe go back to the radius and angle. to work out your x and y, or a and b. I'm going to let Wolfram Alpha do that for me because I feel like I'm going to make a mistake. Unless you need to see that. But okay, you're asking about the process, I guess, which is why I'm worrying a bit more about, or why I'm not worrying as much about that very last part. But I think the process that I've done is okay. Let me bring up Wolfram and see if I got it right. Six I. Oh, heck yeah. At least the first one is right. The trig form is right so far? Okay, good. So that just means I would need to, I think those things are equivalent. Wolfram Alpha just gets the angles a bit differently for fun. I guess what part of the process, or what part don't you know how to get there, I guess, Hauke? So I can try and go back and explain that part a bit more, or is it this part with converting it into algebraic? How do you, I assume there's a, oh, Wolfram Alpha gets it like this, so you can use unit circle, I guess. Actually, let me look. Unit circle. Are these unit circle to get from that part into algebraic? Oh, okay. So let me not gloss over that part. Oh, 7 pi over 6 and 1 pi over 6 are unit circle. Oh my gosh. Okay. So what I did for the first one, for the 6i, that first rectangular solution there, is I literally took cosine pi over 2 and sine pi over 2, and I looked at them up on the unit circle. Let me make it bigger. It's not bigger at all. Ugh. Okay. And so pi over 2 here, cosine goes with x, so we get 0 for that first one, and then sine of pi over 2 is 1, so that's why we end up with just 6i. So we technically get 0 plus, or 6 times 0 plus 6 times 1 times I, that's just 6i. For 7 pi over 6, I'll write that out. It's going to be, let me come over here. 6 cosine 7 pi over 6 sine over 6 is equal to 6 times, now cosine 7 pi over 6 is minus root 3 over 2. Just looking at the unit circle. And sine of that is minus 1/2. And so distribute the 6 inside. 6 cancels with a 2, and we get minus 3 root 3 plus, minus 3. So that's how we get the trig form for, 3i. That's how we get the second algebraic form. And then we do the same exact thing over here. We have to break out our unit circle again. So cosine 11 pi over 6 is root 3 over 2, positive this time. It's root 3 over 2, not root 3 over 6. Sine of 11 pi over 6 is minus 1/2 again. Now we distribute the 6 inside again, and we get 3 root 3 positive minus 3i. So that's how we get the last solution here. 3 root 3 minus 3i. Does that conversion make sense? Because I just unit circled that thing. I hope that's the way that you were taught to do it. I don't know if there is a different way. Okay, the answer that I got match with Wolfram. So yeah, okay, I just literally looked up the cosine and sine values for those angles in the unit circle. I'm not sure how I got the 7 pi over 6 and 1 pi over 6. Okay, good question. So it's just a rule with that comes up in these problems where if you want to take, we have to, I'm not sure the exact part that you're confused on, so let me just explain it from the beginning. If I'm saying something you already know, please don't take offense, I guess, but it has to do with the angles that there's multiple values of the angle that could happen here. So when we want to convert this rectangular or Cartesian into polar, the angle for a theta could have many different values. But kind of like, I think principal angle or whatever it's called is going around the circle, less than once. This angle is 3 pi over 2. That's where I got the base angle from. But you could also go around, do a full revolution, and then come back around, and that's another angle, which is 3 pi over 2 plus 2 pi. And so that's why you always have to do the plus 2 pi k thing, because you could also do 2 revolutions and then come into it. I need to replace the ink in this marker. And you could do that more and more times. According to Anders, you can do as many times as you want, and according to Anders, which I think is true, you'll only end up with 3 unique things. For the reason it'll just like boil down to something nice with the cube root. That's why we get 3 pi over 2 plus 2 pi k, because there's multiple angles to express the same position. And I guess with a cube root, we're going to end up with only 3, and the pattern is always, your principal angle or principal root, whatever, plus 2 pi k, and your k is always starting from 0 and going up to 1 minus whatever your root is. So we're taking the third root, so we go up to 2. So 0, 1, and 2 are the options. We solve for theta by equating the exponents. Divide each side by 3 to get this equation here. And then we just take in our 3 values of k and plug them right in. So 7 pi over 6 so the 7 pi over 6 comes from pi over 2 plus 2 pi over 3 times 1 for the k equals 1 case. Similarly, 11 pi over 6 comes from pi over 2 plus 2 pi over 3 times 2 now for k equals 2. That's how I got those. And I just did the fraction math in my head there, but you get a common denominator, the 2 and the 3. So I hope I covered the part that you were confused on somewhere in that explanation, but please tell me if I didn't. Oh no, Anders, you're all good. I was just referring to what you were saying with allowing any value for k. Raptomate, thank you for the follow. Oh, I'm sorry I missed that. Did the alert not play? Or maybe it did and I just skipped, I wasn't paying attention. Either way, thank you so much. I'm sorry I'm late on seeing that. Think you get it? No? Awesome. I'm glad to hear that. If you have anything else, please let me know. I'm not the most confident with complex numbers, but that specific type of problem I've learned how to do. And Jed, do you still want to talk? I see you're in the live chat. I guess I can just jump in and ask you. Let me get some water first, though. Yeah, sure. So let me get set up to do a to show my Discord too. Hello, hello.
Hello.
All right, what you got?
So this is a free website, circuitverse.org, that lets you simulate logic designs. This might be helpful for like testing things out or whatnot. It's kind of neat because I've created 3 inputs over here on the left, A, B, and E, and then drawn some logic gates around. And as I toggle these things, you'll see different values on the
Ooh,
it automatically to let me
that's
know
kind of
what I'm.
cool.
So what I did is looked at the first thing that Cruz had, which was A or not A, B, E, or A, B, not E. So what I did is first gate here is the not A, B, E, right? So I took the not of A, so I took A, ran it through a not gate, dragged it down, ANDed that with B, which is here, and then
Okay.
took that and it with E, which is split here. And so you can see what that looks like. So if it's got to be not A, B, and E, that means B and E have to be turned on, and A can't be. That's the only thing that fits this solution, right? Because if I change any other value, it turns off part of the gate. Just looking at this output right here.
So I was getting confused on this because the actual answer to Cruz's question, then we're taking that lower part of your drawing that includes the A prime BE plus ABE prime.
So that's yeah.
Everything that
This
connects
part
to
right
that.
here.
Like we draw
So
that diagram for our answer. Everything that like leads up to that output, right?
right. So basically, he was trying to get this part right here,
Okay.
right?
Mm-hmm.
And so I basically split that into okay, do the A dot, the A prime BE, and do the ABE prime, and then OR them together. And
Okay.
so this is kind of what that would look like. What I did then is okay, so he's got the ability to do an XOR as well. So if we factor
Sounds
out the
good.
B,
Okay.
we end up
Thank
with
you very
B
much.
and
Hope you have a
A
good night
XOR
too.
E, right?
Sorry, I was saying goodbye to Hauke.
Yeah.
I'm a bad person. I think A XOR B is like saying A prime B plus A B prime. Yeah.
I would say that's true. Yeah.
So I was saying before with like the factoring out thing too, or we use the same trick.
So yeah, we did the factor out B and A XOR E. So what I did is took A and E and XOR them together, and then AND that with B. And you'll see that this number and this number are exactly the same, no matter what combination I use. So.
Oh, I see. So you did 2 separate like ways to do the same thing here.
Right.
Okay.
So yeah, this part down here simplifies to this, and that's just 2 gates, an XOR and the AND, which is I think the solution that Cruz came up with.
Okay, cool.
And you can see, if B is turned off, nothing you do will turn this on, because if this is off, this AND will never produce a true. And you can actually see the color changes as lines turn on. So in an AND gate, they both have to be turned on, and if B is turned off, that will never turn on, so this will never happen. So that
Right.
has to be on, and then A or E, but not both, have to be turned on to turn on this other gate, and you'll see that.
Okay. That's a
And so
neat
you can
site.
actually kind of follow that logic down here. And so basically this little part right here is what you end up with. This box right away. I can't draw that box. You get the idea. But it's a really neat tool because you have the ability to just drag some inputs in here and toggle them on and off, and then draw your gates and connect them together to see what you get, label them all so you know what they represent.
Yeah.
So it's free to use too. So if you're not, if you're interested in something like that, circuitburst.org.
Might be able to comes up again. So, Cruz, do you have further questions? I'm sorry I kind of like tapped out, but because I was getting confused and I wanted to get to Halkate's question too. But now that I've at least dealt with Halkate's question, it doesn't look like they have any others.
He just posted a comment.
The third is that, and the fourth is just using carry. Okay, so do you feel okay? It sounds like you feel comfortable with them now. Then
is
okay.
E prime, AB, or E, A prime or B prime.
It sounds like regardless,
Okay, yep.
Cruz figured it out. So
Yeah, that was the second one. Yep.
Yeah. All right. Well, thank you, Jed. And sorry, Cruz, that I couldn't figure it out sooner, but at least we have Jed here.
I love this logic stuff. This stuff really gets me excited.
Oh, well, perfect. If people ask about it more, I was like, oh, ask Jed.
I drew
not me.
the full adder up here too.
Oh, okay.
So you got A, so you get 1 with no carry, B, which is 0 with 1 carry, and then E, A, B, and E together gives you 1 with, that gave me no carry. That's interesting. That's supposed to be an OR. I'll put an AND there. Let's fix that.
Oh, that X in the red box kind of stresses me out.
Do what?
the red box around the X like stresses me out. It's like, oh god.
Go. So
okay, we're good now.
Yeah. That's not right either. Oh, that's the XOR. I did an XOR here, so maybe the AND was right. I don't know. I have to go back and look at that. I was trying to compute something else up here, and ignore that.
Sounds good, Cruz.
But it was just a neat little tool that you can actually use to simulate this stuff, which I thought was kind of fun.
Is it possible to model any other kind of logic with circuits?
You can model
Anders, I would think, yeah. Like if-thens and all that stuff. Or Jed, that's what you were saying too?
Yeah, I mean, everything could be, I mean, if it's logic, you can devise a circuit to do it.
Yeah, like first order logic. Oh, that term I don't know.
If A, then B, there's a truth table to that, and you can create a circuit that says, okay, if A is on and B is not on, then that should be false. Because if A implies B, then that's not a valid combination of inputs.
Anders is saying for first order logic, which I'm not familiar with.
Give me an example, Anders.
I'm Googling it right now as well.
Sure.
Quantifiers.
Talking like there exists and for all and that kind of stuff.
Oh, there exists an X, yeah, such that for all that stuff.
Well, given that you have an infinite number of inputs, it'd be hard to simulate through a logic circuit.
I guess that'd be done at the software level. I would think. Or yeah. I doubt you can do this stuff, I think.
Yeah. There's some neat things you can do with it, but
oh, okay, this is like another term for it. Any kind but propositional? Oh. Not to my knowledge. I would think you don't really need it for computing, so maybe there's some theoretically possible computer, but I think just, as far as I know, for a normal computer, you only need propositional. I'm getting out of my depth, though.
Beyond my pay grade.
All right, well.
Cool. Cruz is taking care of them. Good. No, good.
Sounds like it. Okay.
Okay. Bye.
See ya. Okay. And Anders, you said you have a new calculation for me, extra credit time. If you want to drop the problem, feel free. Oh, Jed, was my voice in Discord there? Was it okay? Because I remember before it sounded mangled before. Oh, the quick math. That's right. I'm sorry about that. There was the quick math. It was, let me copy paste it in just so everyone can see it. This is slow math now. Well, I can still work it out here. It was not done quickly. So we have 3 times 3 plus 20 times 6 plus 9, or no, plus, not 9, plus 15 times 9. So we have 9 plus 54. These are all multiples of 9. If you factor a 9 out, it's 1 plus 6 is 7 plus 15 15 plus 7 is 22. 22 times 9 is a number. 180 plus 8, no. 360 plus 18. No, 180 plus 16. 196? $198. Okay, it's a refund anyway. Sum 1 to 20 of n? Oh, that... Oh gosh, oh, is it n plus 1 or n minus 1 for the row? It's 1/2 times n plus 1, I think. So it's 20 times 21 times a half, so 210. That's what I'm saying. Okay. And I missed a few things in chat. So Andrews, if you did have a separate problem, I'm sorry that it took me so long to get to that redeem, but if you did have a separate problem you want to see too, I'm happy to look at that if you thought it was just like a fun one to do. Oh, that was, or saying the problem wasn't very nice, or if I'm not being very nice, then I'm sorry. It's probably true, but NSPQ says, we can regard any computer program that maps in out of bounded size to out, or input of bounded size to an output of bounded size. Okay, and Cruz, I hope one day I could help others like you guys. You really inspire me. Oh, well, thank you so much, Cruz. To be honest, I never felt more stupid since I started streaming. There's so many people who are better at math than I am who just hang out here and chat. But I appreciate the kind words. I just try to keep it to things that I already know. Ooh, 5-watt streak, Jed, rebuilding it. But thank you for the kind words. And I'd say if you did want to start doing something, just be clear about what you can and can't help with, I guess. Oh yeah, that's basically Gauss's sum, Jed. Okay. Oh my gosh, look at all these parentheses. So we have, I'm going to copy paste this. I'm not going to hit enter, but just so I don't look at chat in case someone puts a hint. Also, it helps me to highlight things to look at the parentheses. So we have 1 times 7 is 7. 7 minus 6 is 1. 1 times 5 is 5. 5 minus 4 is 1. 1 times 3 is 3. 3 minus 2 is 1. 1 times 1 is 1. Minus 0 is still 1? So this is still 1. Okay. It's a good 1. I get it. Set a chronometer? Yeah, I mean, quick can mean a lot of things. It can mean quick relative to like the heat death of the universe, you know, or it could be quick, you know, relative to car going 60 miles an hour, you know, who's to say? Get this linear algebra out of my life, please. Actually, that might be a reply from the linear algebra person. Yep. All right, let's see. The prime factorization of 2024. Oh, I'd have to do that manually. I don't know if there's a trick for it. I mean, to be honest, like all of Anders have broken the rules today, but they're still fun. So if it's fun, I'll still take it. It's 2024. I mean, that 4 goes into that. You get 506. I guess just take a 2 out, do it the pleb way. You get we have 3 2s so far and a 253. 253, is that prime or not? 3 doesn't go into it. Is it just 2 3s into 253? Actually, I did say 2-digit. I didn't say the limit how many numbers, I guess. 11 goes into it? Oh my god. Oh, it does. It follows the format. Okay, yeah, you're right, Andrew. I didn't put a limit on the number of numbers. Which I guess Buddha has broken that too. Or not broken, but pointed that out. My intention was only 2 numbers, I guess, but I didn't actually write that. You're right. All right, no, I guess you're right, Anders. Oh my god, that's a mean one. 11 and 23. You got a freebie? Yeah. I mean, either way, you would have gotten your points back. Because I just said 253 is prime because I was too lazy to start dividing other primes into it. After 2 and 3, I tapped out. Yeah, I can't find where this person went wrong either, and I'm done looking at it, so I don't think I'm going to reply to them. I don't think I can help them. What is that, Jed? What is product? Multiplying all those 3 together? 99x squared? Is that what it's supposed to be? 1 times 2. Oh my god. Oh, like that notation. Oh my god. All right, no, I refunded that. Not even gonna try. We need a Gauss multiplication. Surprised no one did the stats one. Oh my gosh. Okay, so for this, it's the middle 90% that they're getting. Um, So you want to look for on a z table where you get 0.95, and that's your upper bound. Okay. 10% divided by 2. That means we want the z values that go with 5% and 95%. Yeah, it was... Jed was getting all fancy with the product stuff, or like, you know, the capital pi, or actually no, is that capital pi that's used for like the product, whatever? I don't know, whatever. Just 99 factorial is simpler. Oh, it is capital pi, okay. Or, you know, it could be really fancy and say gamma of 99. You just want to use complicated things for fun, but... Oh my god, you had, I was literally about to spell use like this. Like, depending on your class, you'd either USE. Oh, it's gamma of 100? Okay, well, it shows to know how well I understand the gamma function. I just see it and I go running the other way. Like, all math I don't understand. I said the gamma function, it's like a generalized factorial that works with like decimals too, I think, or negative numbers also, and you can derive it and integrate in things. I think. I don't get how that's possible, but I never had to use it for anything, so I haven't had to confront it. It's an integral? Oh, okay. I guess that makes sense. Use inverse. It's usually like in the norm. All right, see you, Anders. Thank you for hanging out. Okay. Given is equal to the integral of x to the n e to the negative x dx. Oh, from 0 to infinity. Okay. That'd be a very annoying integral to solve. You made the same mistake. That's an integral you want the di tabular integration by parts for. Convert a polynomial to exponential? You don't really do that, do you? That's why n factorial... Really? I can see where that would come up, I guess. Because all the powers are going to come down and get multiplied. That's kind of crazy. Okay. I guess that makes sense. Non-homogeneous linear ordinary differential equation. Is this where you say that z equals re to the I theta? And even though it's a real differential equation, you take it to complex to solve it? I think this is it, yeah. I just didn't know there's a word for it, but... Yeah, this is it. I don't know, I don't remember the answer to this question, though. I only learned this technique so I could tutor someone in it. It was like really like 2 months ago, too, but I've kind of forgotten how you do that part of it already. I think they're asking about, hey, hoo-hoo. How's it going? Do you change your color? Shouldn't you be in bed, by the way? Young lady. Pink is in your favor? Oh, okay. I like the green. It matches both the mod badge and the sub badge too. You're good? I'm good too. We've had some fun math today. Totally, yeah. You're very like color coordinated. Um, do they give an example? Because I think you multiply the e by a polynomial of one less degree than is in the whatchamacallit? Fun math thought? Yeah. Yeah, you know, what about that? Doesn't look fun. We got imaginary numbers, we got pi, all that good stuff. Exponential response formula. They might just need a different resource than Wikipedia. It sounds like they're asking about the case where... Oh, that's not it. This method to solve a differential equation, it looks super weird, but it's kind of fun once you get into it. I need to find an example that is close to what they're asking about, though. P is a polynomial with real coefficients. don't think I know the answer to this person's question, though. I didn't really learn it in these terms. Yeah, I think I'm going to move on because I'm in a bit of trouble. I think I might like misinterpret their question slightly. Reddit's proof for 0.999 equals 1. All right, let's see. Well, you're starting from the thing that you're wanting to prove. Okay. Oh my god, I'm not. Oh my god, that's way too long. I'm already bored. I'm looking for a different post. Don't you always use k over x? Like you always need a constant? Hmm. I don't know. Oh, yeah, that's all that needs to be said on that problem. Hmm. Absolute value inequality problem. It has an answer. Ugh. All right. Go back over to homework help just because I might have something new. Geometry, do I need to add anything? Oh gosh. Let's see. Oh no. They wrote super light. Given rectangle ABCD, length of AC is x minus 10 squared, length of DB is 48. I think are we gonna equate the diagonals here? Just get a quadratic? Find the values of x? I think so. It's a rectangle, so the diagonals are congruent in rectangle, right? So x minus 10 squared equals 48. Okay, they do the plus or minus, they just separate it out. That's completely fine. And they simplify. What do they mean by do they need to add anything? Oh, maybe if they need to add anything to their justification. We should verify that the answers make sense. Is 10 minus 4 root 3 positive? That's actually, it's cutting it close. I think it will be. Why is that not close? Oh, because root 3, never mind. It was like root 5, it would have been close. But root 3 is just a bit more than 1, so. Even then, root 5 isn't that close. Okay. Actually, wait. Can these both be true in a rectangle? I guess I think both answers are. Yeah, I think both can be valid because we're not giving any other constraints on the rectangle. You're okay. Good to check. Oh, wait. It's not about x being positive. It's about x minus 10 squared being positive. And something squared is always positive. Okay. Seems good to me. It's a good thing to remember with geometry that negative lengths don't make sense, but we'll never get a negative length with x minus 10 squared, since something squared is always positive. So there isn't a trick in this question, but if in other questions, may be possible to have something that looks like an answer, but not actually, but you need to throw it out if it would give a negative length. Okay. Oh wait, I mean, I shouldn't have to verify it, but we could make sure that both these are indeed equal to 48. Oh wait. No, they just have to both be equal to 48 because the 10s always cancel. Yeah, it's fine. Oh no, is this Vietta's? It is. Oh gosh, okay. So it sounds like they did part A, and they're asking about part B. Go away. We need to show. Really? Alpha cube plus beta cube plus gamma cube is equal to 3 alpha beta gamma? Does it rely on the answer to the previous question? Hmm. Yeah, I'm not sure actually, because maybe what they put here is the only thing I could think to do, but I guess it's not right. So yeah, I'm not really sure. I don't think I can help this person. Oh God, no. I'm gonna regret clicking on this. No, it's sine of 1 over x. I don't know if I should do this. Zach? Yeah. We can try it. Because it's like actually what you were doing at the end of your stream. It seems like where you have a given epsilon, you just have to find the delta. So maybe it's not that bad. But you have to actually know. Wait, but this in your case the limit or the function was continuous. Like this is continuous too, but it's erratic. Oh God. I guess you could calculate 0.1. Yeah, okay, you can still calculate 0.1 sine of 1 over 0.1. And the negative version of that too. Or no, you said it. No, you said 0.1 equal to that, and you have to solve for x. How do you do that? Never mind, I'm doing it backwards. Yeah, I bet that graph was interesting. Actually, what is it with the x in front? Maybe I should look at it too. 'Cause I don't know how having the x in front would change things. Yeah. Oh yeah. Okay, I've seen this before. Um. You can't really solve this explicitly for x, can you? I don't see how that's possible. Unless you draw a triangle. Is that what you're supposed to do? 1 over x equals sine 1 over x? Or 0.1? They didn't specify what approximately means, so we're free to choose any delta. It's the real answer, SPQ. Ugh. Yeah, it seems like something you'd have to calculate it numerically. I don't think you can solve this algebraically. As far as I can tell. I'm trying different things in my head, but none of them are working. Or do you just have to actually do the limit? That's probably actually the real answer. You just have to show this limit and make the choice of delta. rather than trying to do the actual computation. And I sure as hell don't know how you do it with this one. Although I've heard that maybe it's coming next week, so... Rise for sine of 1 over x. Oh, did someone else jump in here? No? Okay. Hmm. I think I'm going to take a look at the math Discord. I don't know if I'm going to do a super... I don't know if I'm going to stream for a ton longer, but let's at least look for another question or two. This isn't what I would have said, but it's not a bad thing to tell them either, so I'm gonna let them go and see if the person replies back. Scalar surface integral, I haven't heard that term. Potential of a vector field? Is that flux? Is that another word for flux? Isn't that just a formula? We need Paul. Get Paul on the phone. Where would it be? Potential function, that's what I was thinking of. Find the potential of a vector field. And the potential is the gradient of a conservative vector field, according to Paul. It's not one of those liberal vector fields. Vector field is called a conservative field if there exists a function f such that big F is equal to gradient little f. I think you just take the gradient. I'm trying to make sure that I'm not like mixing up my terms here, or that I'm not like reversing this. This section is out of conservative. Do you know how to code? Cruz, technically, yes. I've forgotten a lot of it, though. So, like, pseudocode type stuff, I can understand. But actually, when I go to actually try and code something for myself, I'm so bad with remembering the syntax. Okay, this is the exact like type of thing. Yeah. So yeah, exactly, Zach. Or like someone asking a question like 2 or 3 weeks ago that was really better answered with programming, and I opened up Python and I was like stuck on how to even start it. But SPQ and Jed both wrote programs in like 2 seconds. Chose something other than C++. But yeah, so like I know Java decently, or at least I did. Python I've been learning, but I don't really know it that well. C++ I learned and I've forgotten a lot of it. Um, but yeah, Chrissy, if you have a question about it, please let me know. MATLAB is coding too, I guess. Oh, well, I've forgotten almost all that too. Was their introductory C++ class? That's right. Yeah, I remember seeing you work on C++ questions. Yeah, I think C++ and Java were my favorites that I learned. Things like Python, I feel like I have no control over what Python does. Do you know how crazy you can do it? Yeah. It's like with C++ and Java too, but a little bit less. Like there's some things that are a little bit like tedious, but at least I know exactly what the code is going to do. And with Python, I just don't have that same feeling. Why are they doing all this funky stuff? So did I get the direction reversed? Oh, I did have the direction reversed. You have to basically undo a gradient. Okay. So maybe I should just link them to this page. To be honest, rather than trying to work out their... I mean, I could work out the question just for fun. How do you actually do it? Um... Oh yeah, so if this is the result of a gradient, you can derive the x component with respect to x. Or the y component with respect to y, or the z component with respect to z. But yeah, you get like a function of integration or the constant of integration because you're only doing it with one variable. I see. Then you differentiate both sides with respect to y. Yeah. Okay, I remember this. It's kind of math, but it's in code trying to understand what they want to have you do. You have input 2, 4, output is 64. Oh gosh, this is hard to read. H sigma squared plus H sigma cubed plus H sigma to the 4th. I mostly have trouble understanding what they want you to do. What is the input 2, 4 thing? Like 2 and 4 are your parameters? And you should get 64 as an output, like some kind of function. And we have H sigma in the mix. Two, 4 means H2. I haven't learned this H thing, I guess. Like 2 hex digits? It's a variable. So do you have 4 inputs with 2 digits or 2 inputs with 4 digits? If I'm interpreting this right. The output is 64. Does that mean 64 digits? I'm getting... Oh, what is this H sigma thing? Oh, dihydrochloride hydrate, I'm sure. Oh, wait, 6 to the power of 2 is 36. Unless that caret means plus. Okay. Oh, it's like summation? I thought the sigma was would potentially mean something else. Yes, this is confusing to me too. I'm not sure what's happening here. 18 and 36 are definitely not, or none of those are. 6 isn't a perfect square, 18 isn't a perfect cube, and 40 isn't a perfect fourth, whatever, however you call it. Yeah, I'm not sure, Cruz. I'm sorry. I don't know what that's trying to say. Is it? 2 times 3 plus 3 times 6. Oh, you're incrementing them each by 1? Huh. Or not by 1. N times triangular numbers. Oh. H2 the first n multiples of n. Oh. Okay. So I don't know why this is helpful, but I guess the math that's happening here is we're saying that H2 is the first 2 multiples of 2, which is 2 and 4, and you add them, and then with the sigma, you do 2 plus 4, which is 6. And then h3 is the first three multiples of 3, which is 3, 6, and 9. And then you add them together and you get 18. Then h4 is the first four multiples of 4, 4, 8, 12, and 16. Add those together and you get 40. Okay. Oh, and they're still triangular, but just with like, it's funny. So I don't know. I don't know why you'd ever want to program this. But that seems to be what's happening here. So Cruz, like the pattern's happening with the H, or like the pattern's happening with the H's here is H2. You start with 2. Exactly as Zach said. You start with 2 and you get the first two multiples of it starting with 0. Or with 1, I guess. So 2 times 1 is 2, and the next one is 2 times 2 is 4. And then for H3, you do 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9. For H4, you do 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 6. And then so you have those like tuples or arrays, or however you want to call them. You just sum each of the elements. So 2 plus 4 is where the 6 comes from. This 18 is 3 plus 6 plus 9 from H3. And the 40 is 4 plus 8 plus 12 plus 16, all the H4s. That seems to be what's happening here. And so I guess that will be a sum of a series, like a sum of a sum. So Chris, I hope that makes some semblance of sense, but if you still want me to maybe like draw it out more, let me know. In the meantime, I'm gonna try to remind myself a bit more about how this potential function thing works. So I definitely remember you take like, you know, x, you integrate in terms of x. I don't remember exactly how you work out the constant of integration here. So you take the partial of your result with respect. They're doing y. I assume you could do y or z first, but do we do y first? We'd expect it, the partial in terms of y to be equal, I think, to this. Which I know I'm flipping around everywhere. Oh, I see. That's what they did. Okay. And we get that becomes 0 because it's a nice example. So don't have to worry about this, a function of only z. And because this is a nice problem, you don't end up getting anything. Okay. Looking over again, maybe you understand? Oh yeah. Okay, Obi, that's a good way of framing it. So we had to integrate this partial in terms of y back in terms of y, and the constant there will be just z. But I don't want to leave Cruz hanging here, so maybe I'll draw it out on the board. Well, I don't think we need this part. Okay. So Cruz, first let's go through and let's just construct our h's. So h to 1, or h1 we don't actually use for the sake of the problem, but we're just going to call that 1, and I think it'll be a bit more clear what's happening if we just skip past this and go to h2. So for h2, we start with this number 2, and we do 2 times 1 is just 2. And then two times 1. So let me just keep that open. Then for the next number, we increase what we're multiplying by 1. So now we're going to do 2 times 2 and get 4. And the pattern that that's going to emerge here is for h3, we take the thing that we're starting with there and we just multiply it by 1, 2, 3, all the way up to the number that we originally had. So this is going to be 3 now. Oops. Keep my coloring consistent here. So this first one is going to be 3 times 1. It's just 3. Then we'll do 3 times 2 is 6. And then we'll do 3 times 3 is 9. And since we've gotten up to 3 here, that's how we know when to stop, I guess, once these two numbers become equal. So again, I couldn't tell you why you would want to do this in particular, but this is the pattern in these arrays, if you want to call them that. I'm doing the curly braces. What did you put, though? Oh, you did the square brackets. Oops. And then let's go through and construct h4 the same way. So we're going to do, oops, 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. Keep going. 4 times 4 is 16. And we've gotten to where these two are equal, so we stop there. And so now we need to work out our sigmas. So the sigma for h2, you just add each of the elements. 2 plus 4 is 6. The sigma for h3, 3 plus 6 plus 9 is 18. Sigma h4, 4 plus 8 plus 12 plus 16. Oh, I'm running out of room here. Four plus 8 plus 12 plus 16. So that's 40? 40. So now, at the final step that they show there, we add all of our sigmas together. Six plus 18 plus 40. So what, 64, we said? Yeah. So Cruz, I hope that helps explain, I guess, the pattern that's happening. Again, I'm not sure what the practical use of this is, but for what you've shown me in that picture, I think that's the pattern that's here, or that's like the math that's happening. You get it now? Okay, good. I'm glad. No worries. SPQ says the sum of hydrogen isotopes turns out to be 1 over 24 n plus 1 n plus 2, 3 n plus 1 minus 1. Oh yeah, and thank you, Zach, for finding that pattern in the first place. To the 2i pi. Who is that? Yariazen, thank you for the follow. Donkey! Thank you so much, Donkey. Playing Lethal Company, I hope it was fun. I appreciate that. Welcome in, everyone. Down with Donkey. Hey, our luck. How's your Lethal Company? It's going good. We've been having a good variety of problems today. I was just about to we took a question from Cruz in chat, and let's Cruz anything else. I was gonna work on this calculus one now. Has anyone else already answered this? No, they haven't. Okay, good. Well, not good for them, but I kind of want to work through their problem now just so I can remember it a bit more. So let me bring up their problem. And I'll put it on screen in a second. Here we go. We need to find a potential function for this. Actually, I can just copy this down again. It's very tiny. I'll just copy it up on the board. We need to find a potential function for a given vector field. I think they've already said they understand how to check if it's conservative, so I'm not even going to worry about trying to remember that. Because I don't really remember how you check if it's conservative. I don't think it's particularly hard, though. Okay. Curl f equals 0. Oh, okay. Okay, so let me copy down the vector field we were given. Seems like a good start. Oh my god, I was about to draw a sigma. One plus y over x squared plus y squared plus 1. X squared y squared plus 1. Let me make sure I got that right. Right? The other one is similar, but there's no 1 plus, and it's x on top instead. So the point is that this is the result of a gradient, and so if we want to go back and get the original function, we got to do some integration. This was our x component that was presumably the result of a partial derivative in terms of x, so let's integrate it back in terms of x and see what we get. X squared y squared plus 1 dx. Here we treat y as a constant for the sake of this integration. Is x squared plus 1 arctangent? I think, yeah. But, oh, no, we have to, oh, no. The y's are going to make it annoying. We need to factor out whether... I need to remember this. That's where they subscribe to Reaganomics. Hey, yo. Oh yeah, trig. Oh man, I never remember. It's not integrating a trig thing, it's integrating something and getting a trig thing. Oh no. Is this hyperbolic? Oh no. That's for hyperbolic. It's not this section, but it's next to this section. That's not that either. Really? Ugh. I'm trying to find, it's a formula like this, but this is a slightly different situation. I want my A's and B's and X's with arctan. Man. Integral 1 over 1 plus x squared. I want this with, I want this, but with constants. I don't remember how you're supposed to, I guess they explain it right there, but I don't feel like doing work. Man, they're gonna make me do work. They're gonna get me started on work integrals. Okay, wait, this might just give me the answer here. Okay, so yeah, our y is basically already factored out. So in this format, we basically have 1 over y squared. Okay. I think I got this now. Oh, whoa. 1 plus y, factor the y squared from the bottom. Dx. 1 plus 1 over y is a constant. 1 plus x squared plus 1 over y squared. Dx. Okay, and then that is in the, oh shoot. Get rid of that. That's in the format that I wanted. So we're going to end up with x plus 1 over y times 1 over a. This is a squared. So we get just y times 1 over y, which actually goes away. Arctan xy plus h of y. And let's do the partial of that in terms of x back just to make sure in Wolfram Alpha, because I'm not feeling that confident in my integration. Bam! Got it. Okay. Okay, never mind. That's a little like something else for a minute. Okay, so we have this, and now we want to take the partial in terms of y. And this is basically an incomplete answer for our function f. So now let's get the partial in terms of y so we can figure out what the constant is here. Yeah, okay. Partial in terms of y. That goes away. That becomes, doesn't it become that? So I think we're not going to get a constant, or at least not another function of y here. Wait, no. Don't we get a 2? Because if you... No. partial of that in terms of y. Oh my god. It is just this, or it is just that, because we worked out the problem in reverse up there with x. So I think h sub y equals 0. Which means h of y is equal to some regular constant c, I think. So I think that means our final answer for f is x plus arctan xy plus c. Okay. And let's verify that partial in terms of y just to be sure. I enjoy multivariable calc, but it's been so long as I've done it that like I'm rusty on almost every part of it. So let's not take any risks. We get the y component back. Good. Okay. I feel confident enough to answer this person's question. Let me get the link to Paul's notes. Now let's go back to Discord. Spectry? Yes. Yesterday during code names, it was like late at night for me, so it was like some ungodly time for you. But yeah, Andrew Chavez is a complete legend. I have a bunch more emote slots that I need to fill now. I never said a new sub goal, did I? I feel bad. I feel kind of bad putting my sub goal up to like 75. But I don't know. Basically, so f is the result of a gradient, which means the x component is the partial of the original in terms of x, and similar for the y component. I'll take whatever I'm given. I'm not gonna... Yeah. You can integrate the x component in terms of x. The first step to find f is to integrate the x in terms of x, or the y in terms of y. And then it's just a bit more work from there. This site has nice examples showing the technique. Some example problems, or if you look at the example problems. Okay. Let's see if the person gets back to me. Oh, is this an induction? Is that the nth root of n? How do you do that? Oh my god. I need to zoom in and enhance on that if I'm seeing this right. It's the nth root of n. Oh my god, how would you do that? The square root of 2 is less than 2 minus... Okay, yeah, that's true. Square root of 2 is like 1.4. 2 minus a half is 1.5. I feel like I can't do this, but I kind of want to see if I can. Let's try it. Yeah, Obi, that's what I'm thinking. Or not Obi, Zach. That seems like something we're gonna have to do here. Prove for n greater than or equal to that the nth root of n is less than or equal to or strictly? Strictly. Uh, 2 minus 1 over n. Okay. So, just do the base case quick. This person already understands it. Square root 2 less than, I'll write 3 over 2. So we assume this. We want to show the n plus 1th root of n plus 1 is less than 2 minus 1 over n plus 1. Okay, so if it changes your candy cane fleece PJs, hey, it's Saturday. Oh, I see someone sending in the Discord right now that, actually, so I don't know if taking the nth power is the right idea here. I don't see necessarily what that does, although it might just be me, so I think the person, actually, I kind of like the train of thought that the person in the Discord is saying, which is to start with, or it's the other way around? You start by proving this, which I didn't realize was even true. And that would get you where you need to go. Would you do the nth power here, though? Like, how would you go about doing that? That's not clear to me. Show the limit as x approaches infinity of n to the n plus 1 over n is equal to 1. And it's monotonically decreasing, you think? Like showing that the exponent would approach 1? Or not series, just proving this inequality for all n greater than or equal to 2 inductively. So the hint that someone's saying on the Discord is to try proving this, which seems like it'd be great if we can prove that. I think that's the hard part. Show that. Wait. N to the n is decreasing for n greater than 3? Oh, n to the 1 over n. Okay, that makes more sense. Okay, I was like, I don't think that would be decreasing. I wonder what class this person is in. Because that could be not something, or like, I feel like the technique would be kind of informed by the class here. It's like, either way, I don't think I'm going to type anything in Discord because there's already people who are working on that problem. I was kind of curious to see if I could understand it, which maybe then I don't need to worry about what class the person is in. I think this is useless. So, Zach, your idea, it sounds like it's not even induction. You're just showing that this is decreasing monotonically, presumably to 0 or something that's less than 1/2. Like, this is the obvious like limit idea here that's going to, or 1.5 or 3/2. You show that this limit would approach something less than 3/2. Don't think even close. And so whenever n approaches 1, that makes more sense, yeah. Yeah, okay, yeah. So, I mean, I mean, this wouldn't be helpful to the person who's asking the question, I don't think, but still interested to kind of see this play out. It's like, in my mind, I'm just forgetting about the induction here completely and changing it into a limit problem. That's a horrible infinity. Oh my god. It's like halfway between an infinity and an 8. It couldn't decide which one it wants to be. So, I mean, for this, I would do like the little like equal to L trick, and you do the ln of each side. Like, I don't know. Even though, like, I think it's technically wrong, right? But just to get a value. And that's L'Hopital's. So you get 1 over n over 1. That becomes 0. Is that good? Oh yeah, because we do e. Yeah, okay. I was like, ln of 0 doesn't make sense, but we don't get ln of 0. Wait, so L equals e? No, L equals 1. L equals 1. Okay, that makes sense. Just ignore the first thing that I said it was. And I did it right in the first try. Okay. That argument, definitely easier for me to make than the induction argument. I think they're supposed to do an induction argument, but that is interesting to see. How do you get a blue name? Active? Oh, I don't know if that's new. Oh wait, there's a new thing in Yoshi. This site was what I needed. Oh, hell yeah. We have a new convert to Paul's online notes. Okay. Will Desmos graph this? It's almost like... Or was for n greater than e? Yeah, alright. Never mind. I'm satisfied enough to like move on. Group? Nope, 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 nope. What the heck? I might rather look at it something with the groups I don't even understand. What is this? Do you rationalize the denominator or like I should get this to Penn Center, even though I think it's probably too late to submit integrals. So it looks mean. I have no idea how you'd do it though. Integral 101, yeah. Is it gonna be odd or something in like 0 to pi over 2? It's gonna be symmetric or like between pi over 4. Sine of x. Puzzle notes how you passed all your math classes? Dude, I love puzzle line notes. It helped me out so much both as a student and now doing a math stream. Like half the stream here is me just linking to Paul's online notes because it's so good. But I think this one is not going to be on Paul's. Let's see what this graph looks like, I guess. I'm kind of curious what's happening here. Because my first instinct is to look for a trick to not have to do this terrible looking integral. Square root sine of x divided by square root sine of x. Exit square root plus square root cosine of x. Okay, what's up with this? Oh. What? It's half of a rounded rectangle, basically? I don't even know how you get that. Does it end at pi? It ends at pi. It's periodic? Oh my... What? They're like stones in a river. Yeah. So they need to do from 0 to pi over 2. So unfortunately, we don't get some neat trick where it just turns out to be 0 or something. 0 to pi over 2, right? Yeah, 0 to pi over 2. That's a cool one, yeah. So, what happens to rationalize the denominator? This has me intrigued. Okay, integral 0 pi over 2 root sine x over root sine x plus root cosine x. Oh my god, I should have given myself some more room. So actually, okay, let's just do some mental math on what the result will be of the rationalization. Okay, so we're gonna multiply by this same thing, but with a minus sign instead. So on top, we're gonna get no square root sine x minus They can share a square root. No, it becomes minus now. Does that help us in any way, shape, or form? Well, we could split up the numerator. I don't know if that really helps us, though. This almost looks like if there's another cosine x over there, it almost looks like something they could factor. What happens with the, like, what happens when you derive, like, okay, maybe it's not this, maybe we just do a u sub, like u equals, like, what's the derivative of this? Oh my god. Oh my god. Oh, I hate that. Cosine is going to be, like, basically the same. Oops, cosine of cosine x. Yeah, I don't think either of those really help us, do they? I assume you have to get some kind of cancellation here. Because I don't see a u sub going anywhere. If you did a minus cosine x plus cosine x on the numerator, does that? I don't think it, no, it just gives you kind of an equivalent situation. I don't know. I bet there's some neat solution to it. I don't really see it though. Yeah, I don't know. It could be you have to square the integral. I don't know if I want to do that though. It's a lot of algebra. Oh, and they closed it? Wait. What? They deleted their message. Oh well. Y of 0 is root 3 over 2. Where did I substitute this value in here? Well, you substitute the root 3 over 2 for y. Substitute the 0 for x. I don't see what's wrong with that. It's the group person. Ooh. Oh, it's an improper integral. Why are they talking about the series? Oh no, this person's bringing up integral test backwards? I don't think that's the play. Show or determine whether it converges or diverges, and then evaluate if it converges. To see if it converges or diverges, I would just graph it. I don't know if that's what they're supposed to do though. So I see this person. What's the answer supposed to be? Number 14. Zoom and enhance. Well, this is a bit of a harder problem now, isn't it? Wow, the initial question is they phrased it looks much more innocent. Oh, I see. So I saw that it was closed here, and then they reopened it. It is C is pi over 3, but I couldn't arrive at the answer. So is this their work or the problem? It's just the answer. I bet we need to draw a right triangle here. Reformatting the answer you got. Let me see if I can work it out. Okay. Their answer might be right. I think you can solve what they got explicitly for y. So we have arcsine x minus arcsine y. And they said they got pi over 3 for C, which I believe. Yeah. So let's isolate arcsine y. Take the sine of both sides. And I assume we got to do a subtraction identity there, because sine of something minus pi over 3 doesn't have a pre-made identity. Okay. So we want sine of something minus something is sine of the first thing times cosine of the second thing minus, to match the sine of the second thing. Yeah. Times cosine of the first thing. Okay. So Sine of arcsine of x is just x. Cosine of pi over 3 is a half. Sine of pi over 3 is root 3 over 2. Cosine of arcsine of x requires us to draw a right triangle. Arcsine, well, sine is opposite over hypotenuse. And so if arcsine of x is hypotenuse, opposite is 1, which means by Pythagorean theorem, this remaining side is root x squared minus 1, right? So cosine of this angle is adjacent over hypotenuse, which is root x squared minus 1 over x. I don't think that's what the answer key had, though. Let's see. And that's either I made a mistake or they made a mistake, if it's not. Oh yeah, they don't have the over x. And they have 1 minus x squared. Did I do something wrong? Oh, yep. I don't remember what sine is. Ugh. Sine is opposite over hypotenuse, and that is x over 1. So opposite x over hypotenuse 1, 1 minus x squared. That gets us to what we want. Okay. And that, does it match the answer key? Oh no, I have a minus sign. They don't. It should be plus root 3 over 2 according to the answer key. Sine of pi over 3 is positive, though. Let me verify if it's positive pi over 3 or arcsine x minus arcsine y. And so their initial point was 0, 0,3 over 2. So they did arcsine of 0 minus arcsine of 3 over 2. Arcsine of 0 is 0. Arcsine of root 3 over 2 is pi over 3. So C is minus pi over 3, and that was the issue here. What subs? Like subscriptions, hoo-hoo? Like Twitch's $5 a month thing that you can pay to a streamer. If that's what you're referring to. So it should be equal to minus pi over 3, which makes that a plus, which makes this an addition identity, which converts that to a plus, which converts that to a plus. Okay. Ah, so they did take the sine of each side. They didn't do it right, though. Okay, so we need to correct... I think C is supposed to be minus frac pi slash pi 3 From there, you have the right idea with taking the sine of each side, but sine arcsin x plus but to simplify sine of arcsin x plus frac slash pi 3 but simplifying that the right side should be or simplifies as, I guess, sine arcsin x plus fraction pi over 3 sine arcsin x cosine slash frac slash pi 3 plus sine slash frac slash pi 3 close parentheses. Okay, cosine arcsine x. Like that, I hope. Hey, Malcolm. The answer is 2 pi sine 56. Oh, thank you. Saved me a lot of work there. To simplify, cosine arcsine x, we'll need to draw a right triangle. Okay. See if my LaTeX actually worked out. Something, why is that italicized? Well, I think it just looks weird, but this is okay. Okay, I think it got formatted as I wanted. We don't have subways in here. Shouldn't have moved. No $5 footlongs. Oh, Yaria, thank you. I'm not that good with LaTeX. That makes complete sense, though. I hope it'll work for arcsine. I don't know if... I only know the very basics of LaTeX. Let's see if I can make this work, though. Aha! Paypen, yeah. I just learned that you have to put a slash in front of your sines and arcsines if you don't want it to be italicized. Chicken teriyaki was goated. Is it not anymore? And ln? Oh yeah, I guess any text. Or any whatever function. The music did stop, and I was so focused on the math that I kind of forgot. What am I gonna play? Let's go. This song's. I've been liking this song. There we go. See yourself when you forget, and the text comes all gross. I mean, I was about to leave it, but if Yaria didn't happen to put that, I would have been like, yeah, oh well, it's still readable. Um, I was thinking about only mathing today. Did you want to do Daisy? Because I might be down to hop on, to be honest, if your internet is working. Math server is nice and full. Oh my god, I didn't even scroll all the way down here. Yeah, this thing... I haven't been on for super long today, but yeah, there's a good volume of questions here. Oh geez. I don't know about this, Rick. Maybe an Ocarina of Time / math stream. Oh, are you gonna are you still doing your 100% run, but every time you take damage, you do a math problem? That'll be cool. Probably just curious if you're gaming or it's just a math stream. Oh no, I don't have a plan. To be honest, I only meant to stream for like 2 hours today, but in typical me fashion, it just turned into 4.5 hours. Yeah, I was planning to only do math today. I'm trying to think. Then went out for snacks and you're still streaming. Yeah, I mean, I don't know why. I probably should try and like limit myself, but I don't know. It's flowing. Vegan buffalo Sammy. Ooh. Are one or both of you like vegan or vegetarian, just out of curiosity? Let me get the picture. Just cow free? Okay. No, I just asked because I'm a mostly vegetarian, so I just eat meat on like special occasions or just like every now and again. We do dabble in the dark arts known as veganism. Yeah, I mean, oh, it's actually, let me be more curious. Malcolm, yeah, I think for Daisy, maybe let's just keep it to what we were planning before, because I don't know if I can want to stream super much longer. I think it is. Pure Imagination by Base T? But yeah, no, that was the first thing that I thought when I heard it too. It sounds like the Willy Wonka song. Sort of curious, I usually don't want people to raid on Saturdays. I know I'm gonna be streaming for a ton longer. Yeah, I don't see anyone on right now. Like I'll keep on doing math. I was just curious if anyone's on now. Do you have an idea for when you plan to do that? Zelda pen? And no rush at all if you're not gonna do it sometime soon, but because I'm still planning on doing math for a bit anyway. But if I can go until you start your stream, that'd be great. If it doesn't work out, then Ruby's policy also. Oh, okay. No worries. I'll just look when I'm wrapping things up, and if it works out, then great. For another hour? Oh, I mean, that's pretty possible. I'll be still going for an hour. What's happening here? Oh, Malcolm, I think I'm just gonna do math today. I'm kind of tempted to like do Daisy, but I think we're gonna be playing for like another. We do like a good like few hour run, and I think I shouldn't stream for another like few hours. So okay, Salt of Revolution. We have a line. All right, sounds good. Thank you. If you have for a differential geometry problem, it's a pretty fun one to keep you occupied. Pretty surprised by the solution. Find the envelope of the family of straight lines. I haven't taken a differential geometry class, to be honest. The envelope of the family of straight lines on which the coordinate axes cut off a segment of constant length A? I'm not familiar with the term envelope. Whoa. Yeah, I don't know if I'll be able to do this. That. Sorry. We've had some suggestive looking graphs today, and this is definitely one of them. Boo, policy. Good thing it's not no. Yeah, exactly, dude. Yeah, it failed. Yeah, let me, turn off this cam. I got some business I got to take care of quick. BRB. So yeah, I think that was gonna be a little bit out of my wheelhouse. I sometimes will do math for fun, but all times I'd rather do homework help questions. Although sometimes they just grab my attention for fun questions. Let me try and describe this in words, and then I'll offer to draw a picture. So what I ended up with after using the identity and simplifying is slash frac 1 2 x plus root 3 over 2 plus slash frac slash, is it square root in LaTeX? Security, okay, thank you. Okay, yeah, so that's good for my braces. Oh, you do the square braces for higher roots. Okay, that's good to know. And then now we do slash cos slash arcsine of x. Okay. When simplifying the cos arcsine x $, the is an angle in a right triangle since sine is opposite over hypotenuse, hypotenuse, like that, yeah. It's not yelling at me with the red squiggle. Our right triangle has opposite angle x and hypotenuse 1. Since x equals x over 1. Okay. By Pythagorean theorem, the remaining side is square root 1 minus x squared. 1 minus x squared. So the cosine is adjacent over hypotenuse. So cosine arcsine x is equal to slash frac slash square root 1 minus x squared over 1. I need another brace there. That should be a brace. Right? Let's see if this actually compiles. Oh, wait, no. If that's more helpful than words here. Oh no. What didn't compile? Oh no, I didn't close a dollar sign? I did not close a dollar sign. Less money, more problems, as it turns out. How does that look? I use the word so and since like a million times in this, but I think I'm gonna roll with it. Now this thing's shared to the picture. Let's see. Oh God, man, it took like 2 seconds to read it. Ugh. Okay, let's make a picture. Okay. Let's just erase all this. I was hoping at least like would try to follow along with the text explanation, but okay, so we have cosine of arcsine of x. Let's look just at the arcsine for a minute, not worry about anything else. So then sine of theta is equal to x over 1 is equal to opposite over hypotenuse. So I'm going to go to draw our right triangle, label an angle theta. That dot shouldn't be there, it's going to annoy me. Root 1 minus x squared. Pythagorean theorem. Cosine of arcsine x is equal to cosine of theta is equal to root 1 minus x squared over 1 is equal to root 1 minus x squared. I hope that's enough of a picture for this person. Let me take a screenshot of this on my stream. Go to Twitch. Okay. What's this? Oh, I got gifted a sub to someone. Okay. That's nice. Okay. Damn. Oops, I wasn't showing that. Yeah, I'm not going about getting a gift sub. WED free for a month. Wow, this person's replying instantly. Did they even? Thank you very much, Penn Center. I appreciate that. Oh, that's very kind of you. Yeah, I sure enjoyed that one too. Okay. That helps. I get it now. That's exactly what I wanted to hear. Oh, yeah. They're asking where the 1/2 x comes from. You sure, Penn Center? You could try. No, I'm kidding. Please don't. Yeah, no, what can I say besides Andrew Chavez is a legend? Hopefully that gets this person all set. Let's see if we can find a new one. Ooh, what's happening here? A little blurry. Below is the graph of f of x. For each of the given points, determine the value f of a and the limit as x approaches a of f of x. Oh god, okay. If any of the quantities do not exist, clearly explain why. I always forget the rule with a hole like this. If the function is defined somewhere else, the limit does not exist. Like, for here, since the function is defined up above, the limit does not exist. I know that's exactly what I'm thinking of with, no, it's not continuous. That's the definition of continuity. That sounds pretty decent, Obi. I don't know. I'm not sure who that is, but I wouldn't complain. So the limit that wouldn't exist either because we wouldn't be within epsilon of the value of the function at that point. But, well then, if you don't define it somewhere else though, I think the limit does exist though. Wait. Oh no. I usually just Google this when the issue comes up and I don't try and think about it from a theoretical perspective. I might just have to do that again and then reverse engineer the explanation is supposed to be. Oh wait, It's not say f of x at that, no. Okay, so it's not f of x at that point, it's just f of x around that point. Because x is not going to equal k. So the limit is whatever it looks like the function should be. Even if it's defined up there, we don't care about that for the sake of the limit, I think. And someone else is already getting to this question anyway, so it's too late, but this person said so I'm interested in this case with -1, and this person is saying to recheck. Oh, spent on Selena, Aaron Stevie, and now Hoodle streams gives an insane amount. Oh wow. Oh, I do remember seeing that 100 gift sub bomb and Muhoodle stream last night. So this person said, f of a is whatever it's 3. The limit, I would say, is 1. I guess. Continuity requires that the function equal itself there, but the limit existing does not. Okay. Just to use my brain for once in my life. Doesn't seem right. This seems better. Okay. I mean, either way, other people are doing it, but it's good for me to. It seems like the type of thing that I should know offhand that I forget every time I Google it. Where did root 3 over 2 come from? Make sure I'm copy pasting the right thing. Oh no, I did a space. Oh, it's fine. Oh no, I didn't do the slash. It's not fine. It's not fine. Okay. How dare. Okay. Bread? Sorry. Okay, what's... Oh, it's one of these. Ugh. Wait. Calculus, though. This is me, like, attaching a trig function to something that's periodic. Oh, it's work? Oh, gosh. This might be an interesting problem. And I need to remember exactly how work works. How work works. How does work work? Was that Rihanna? Man, I don't know my pop songs. 20 feet wide and 30 feet long. There's 6 feet of water in the deep end. Wait. I thought it goes from 4 to 10. Wait. Sum the force over a distance. Oh, is it not full? Maybe it's not completely full. That's a weird way to phrase it, though. Because I'm confused why they say the depth gradually increases. Yeah, okay, you're going down, but that's an increase for depth from 4 to 10. Then there's 6 feet of water in the deep end. So I think the pool itself goes from 4 to 10, but it's only filled with water so that the deep end is 6 feet. Is that the interpretation? So at the shallow end, it's only 2 feet? So you have like a trapezoid? Maybe? Be empty at the shallow end? Oh yeah, you're right, duh. Because you do 10 minus 6 is 4, not just 6 is greater than 4. Okay. But if That's a weird, it's like a pit more than a pool. You just have some like walls that are just 4 feet tall. That's so weird. Okay. Like, feels like a swimming pool you can't get out of. With how I'm picturing it. So you have a triangular. Actually, let me see what's up with this person first. All clear? Okay, good. Okay, well, let me just draw this, I guess. This some ridiculous pool where if you fall in, you can't get out. So I'm gonna draw how I'm like picturing this. Where's the pump placed, by the way? I guess, or where are we pumping it to? Like, how high? I guess just out of the height of the pool? Maybe that's why they have the extra slack. Okay. So how I'm imagining this is if we look at like a cross section of the pool, it's like this. And the water goes like that. And so if you're like desperately trying to get out, you better hope you're at least 4 feet tall, I guess. Don't let any kids in this pool. Sims core? Is this Sims? Or was there a Sims song? I remember just hearing some weird noises. Okay, so the depth of a swimming pool increases gradually from 4 to 10 feet. Four, 10. Let me get the question so it's actually displayed on the stream, right? That'd be intelligent. There we go. Okay. I mean, this is like a messed up pool from the way that I'm imagining it. Or 20 feet wide and 30 feet long. Okay, so that means, well, which one's width and which one's length? Is this 20 or 30? Or do I have it completely like... We don't know where the increase is from. Do we, like, if we're looking at the pool, like, up in a helicopter and looking down from the sky, does the ramp go like that? Or does it go widthwise or lengthwise? Like that. I know that's horrible perspective, but... Or maybe, no, it should matter. Actually, and wait, and how's the pump, like... Is the pump, like, going like that all the way to the bottom? I don't get this. I'm gonna be honest. I don't know what the situation is supposed to be. Excuse me, you stay there. I don't think I can do this problem. I don't get the setup. The depth to be changing along the length? Really? So my drawing would have been going like left to right. It's a typical poorly worded physics problem. Um, we can see if we can make sense of their work, I guess. Because maybe in the context of their class, they're used to having to interpret this type of vague problem. Because they listed the integral that they tried. The sad bread makes me really sad. Like, that's the main reason why I wanted to help this person. Oh, what's a Kendrick Lamar album? Oh, dude, now I really want to help this person. I have a Kendrick Lamar album. Okay, what? How can we help this person? All right, I need to consult with Paul. Paul must know the answer here. Let's let's start with work. Integrate force over distance. Wait, okay. We're pumping water out of the pool. So I assume the calculus is going to, like, if you just stuck the pump in the very bottom and let the water drain to the pump, I don't think it's a calculus problem. And I assume they're supposed to use calculus, so maybe you're keeping the pump at the very top and, like, shifting it down and down as the water level decreases. I think that would make it a calculus problem. And we need to pump it up at a minimum of 4 feet and a maximum of 10 feet. I think I'm starting to make sense of this. The depth of the swimming pool increases gradually from 4 feet to 10 feet. 6 feet of water in the deep end. Ooh, what's a... They're kind of forcing things. The negative endpoints. I think you're going to go between 0 and 10 here. Or negative 10 to 0, depending on how you want to define things. This person, they're forcing the origin to be basically at the top, and they're going to the negatives and coming up, which, as far as I know, is valid. So the weight of the water is 62.4 pounds per cubic foot. I don't really know, Malcolm. I think if you did it like that, it's just not a calculus problem, and it seems like it's supposed to be a calculus problem, so you have to do things harder for no reason. Well, yeah, how I'm interpreting it is if you just stuck the pump at the very bottom and you just kept it there like someone would naturally do, you're always sucking up the water from the same depth. And that's a much simpler calculation, I think. Yeah, no, Malcolm, you're doing the reasonable thing. I don't think this problem is asking you to do the reasonable thing, though. It wants you to do math at any cost. I think. Randall Knight's physics textbook. Oh, I'm not familiar with textbooks to like blame a certain person, but this I definitely I'm not a fan of this problem. Calculate differential if you move the end of the hose while doing squats. Yeah. Yeah, because you just get the entire volume of water in that case, Malcolm, and then the distance will always be 10. No, I appreciate the discussion. But when you vary the distance, that's when you get a calculus problem. So where are we getting this line from? So we need to work out, I guess, the force. Well, the force of the water is 62.4 pounds per cubic foot. So we need to work out the volume of the water for a very small piece of it. Like this is going to be the volume. Like we do as a very small cube. We need the... I know, I honestly, as American as I am, I don't like using imperial units for physics problems. It makes me want to hurl, yeah. Yeah, it definitely, they just want you to do math. Slugs per cubic foot. So I think one of these is the height of a very tiny box. The other is the width of a very tiny box, and the dy is whatever the last dimension is of a very tiny box. Okay, so here they... Okay, well now they need to do y minus 0 though, don't they? Not 0 minus y if they're doing it like this? Why are they getting plus? 5y times 20. No, I'm not visualizing the inside of the integral right. Let me look. I need Paul again. Density times volume. So we do need to work out the volume. So there, they're approximating the ith subinterval as a cylinder. Here, we're approximating it as a rectangular prism. So maybe I was on the right track. Ah, okay. I don't think this is right. Oh, I assume that was unfortunately timed. This is the problem, Castle Bravo test. No, yeah, no worries. Oh wait, I'm not showing my Discord. That's the problem right there. Okay, so we need to work out the volume of each horizontal slice of water. So we can define... Oh God, how do I want to define this? could do a 0 to 10 thing. Let me I'll bring the problem up. Let me do it the way that I had it before. There. Okay. Yeah, I think we're doing rectangular prisms here. We got to be careful about how we do them. Okay, so I think we would say this is our shorter length. That's kind of an assumption, but 20. And then like the three-dimensional, I don't know. The other dimension is 30. 20, 30. Wait, that's a nest sound. What is this? Okay, yeah, they're just putting video game sounds in their song. Okay, anyway. Okay, I think that's the situation that we have here. Well, plus the walls that trap you in, but I'm not going to draw this in that one. Yeah, a nest mixtape, exactly. Okay, so basically I'm imagining some dude with a straw who's like sucking up the water and they're like gradually getting further and further in with my drawing here, but you know, it's just how it goes. Okay, so if we define, oh God, should we make that our origin or should we make that our origin is the question. Or should we make that our origin? No, I think it should be that or that. And I think we can just arbitrarily do that. Wait. I'm filling a rectangular prism, not the triangular part? I thought, so the water's sitting in the triangular part and we just have to pump it clear up past the edge of the pool. There's already 6 feet of water which fills the triangular part. Out. Oh, yeah. So I think we're still going to use rectangular prisms here as our approximation for each like infinitesimally small bit of water. Wait. Oh, I hate that. I'm not defining. No. But I also hate this. I hate everything about this problem, I guess. How am I going to define my origin? We're going to use some messed up coordinate system. I guess, all right, let's just do this and see what that looks like. Okay, so we're going to be in the negatives, and that's just the way it's going to be for the way that I've been doing this. Well, we have to do it I wonder how they were doing it. I'm not going to worry about that. Let's just try and get to an answer. Your hatred for lower division physics courses is being justified right now. I remember having an issue like with a problem this vague in my physics class. What is this point? It's we rise 6 and we run 20. So we can get the equation for that line. Y equals minus 6 over 20. simplifies to 3 over 10 x. Okay. Maybe this is the most difficult way possible. Yeah. What if you define it at the water level? Get a negative potential energy and a mass. What? Oh gosh. A moving origin? I don't know how that works, Castle. Defining the downward direction as positive movement? We could. Yeah, it'll make like the equation for that line a little bit harder, but yeah, I mean, I'm not a big fan of what I'm doing here, to be honest. We can take a different origin. Like, 'cause maybe we want to do the origin of there, even. Yeah, I think I want to do the origin up there. Well, I mean, we can at least investigate that. Okay, so that means this line goes from 40 to 2010. It's a good year. I don't even know what happened in 2010, but so y-intercept is 4. The slope, this is a positive slope. 10 minus 0 is 10, over 20 minus 4 is 16. 10 over 16 simplifies to 5 over 8. Okay. You have negative potential energy of that water mass. Oh, at the current water level? Sorry, I was misinterpreting you. Oh, you might be saying something that's right, Castle Bravo. I assume that we wouldn't. That does seem like a decent simplification. Like you're saying that the problem of moving the water from here to here is easier than the problem of moving the water from here to here, so do them separately. Or is it, I'm not sure, like I'd have a hard time working that out for myself, so I'm going to do it the way that I'm more used to, but that sounds valid to me too. Okay, so we need to do some work here on our little red slice. So the, I guess, height of the red slice is going to be our dy. The width is going to be, well, yeah. How do we get that? It's going to be 10 minus that, right? Like 10 minus whatever the line happens to be, and then when x equals 20. No. 20 minus that. Right? And then the three-dimensional thing is 30? Constant? The slope for this line I got is 5 over 8. Those are the coordinate system that I chose. This doesn't feel right though. I feel like that's not right. Positive slope because down is positive, which makes it a positive slope. If I'm following my own coordinate system right. That's also 0, 4, not 4, 0. That's, oh my god. Is that 2010? That is 2010. That's 0, 4 though, not 4, 0. Which that does mess up my slope. It should still be positive though. I think, with the origin that I chose, or the coordinate like system. 10 minus 4 is 6. 20 minus 0 is 20. 6 over 20 simplifies to 3 over 10. Ah. I don't know, it still doesn't really feel that right to me though. 20 minus slope times y position. So at least what I don't get about, it's like, is it the slope when y is in terms of x, or the slope when x is in terms of y? That's what I'm feeling weird about, because I'm saying that the integral needs to be in terms of y, I guess. So I think maybe I need to re-express this with y. So it's actually going to be 10 minus that in terms of y. That makes, I feel a bit better about that. Um, 10 thirds y minus 40 thirds. The width is compared to the starting value of 20. Yeah. I guess you're right. I don't know. I was just feeling like the width is like an x measurement. So we should use a y measurement if we're going to do our line in terms of y. We could try setting up some integrals in Wolfram and seeing if we get to the right answer with something like this. Because the person posted what the book answer is. So in terms of y directly, yeah. Oh no. So this person has posted a bit more in their chat, or in the chat here. They did the opposite. They called that side 30. Let's not think too hard about that yet, though. Oh, so maybe this person... I don't understand their integral. Let's look at my own thing first. Wolfram? What would the bounds be here? So we're defining positive y as down. So if we're going from, I think 0 to 10, and then we need the density of water, which is plugging your tablet. All right, 62.4 times all right, so we need to work out the volume of water since we have the density. So dy is the up and down, whatchamacallit, length. Now the width of the triangle, which I'm using my terms horribly here, 20, we'll just put directly in what I was saying, 10/3 y minus 40/3. Times, if my work could be 30. 312,000. What is the answer supposed to be? 673,920. So I'm slightly off here. If you can believe it. I didn't do something right on the first try. I need to double this. What the hell? At least. I'm getting some cancellation. Wait, no, that's because I was doing that. Okay, that's at least one solid thing. How the hell do you do this, dude? If y is going from 0 to 10, we might want to do the line minus 20 rather than 20 minus the line. How does that work? Let's just try it and see what the answer becomes. That's a much simpler thing for me to do, I guess. Nope, that just negates it. That makes sense because I factored out a -1. Okay. Even if I didn't mean to. Oh. Did I rearrange the equation right? I think I did. Y equals. From y equals 20 to the line. Huh. I feel like something is oriented wrong. Like, I feel like... Because the integrals in terms of y, so if we're doing 20 minus something, that's going to be y equals 20, going from 20 up to the line. And that's like, the sights are going up and down with that. And that's not at all what we want. I don't know how, so how do we get what we want then? Maybe I shot myself in the foot with the way I drew it, now that I think about it. Or at least I made it a little bit harder. Like, I could have flipped this and still had a valid problem, and my coordinate system would be a little easier to work with. Let's try working this out. Let's just flip my entire drawing here. That one is fine, but... Or 20, 10, 6. Oh man, I need to replace the ink in my blue marker after this stream. So let's take our same origin point. If we hit this, we maybe get something that's a little bit easier to deal with. So this is the point 0, 10. This is the point 24. So then we have y equals 0 minus 20 is negative 20, 10 minus 4 is negative 6, or 10 minus 4 is positive 6, so we get negative 20 over positive 6, which is minus 10 over 3x plus 10. Okay? Seems reasonable so far. So the thing that I was struggling with before is the width here. So let's just think about in terms of x. The width is going to be 20 minus x, because when x is equal to, no, the width is just x, and x goes up to 20. But we need to change things to be in terms of y. So if we rearrange this equation here, the x equals minus 3 over 10y plus 3? Yeah, okay. So this is also 3 minus 3 over 10y. And y goes from 0 to 10. So are we just building in? Wait, from 0. That's important. Maybe you do need to split up like Castle Bravo was saying. I feel like maybe the 0 to 10 business is kind of messing it up. Let's go back to Wolfram. And if I can't get it soon, I will look for a different problem, but this one, it's just kind of, it's piqued my interest. Try setting up a new integral. So if we do, we're starting at y equals 0. Which the more I look at it, the less it makes sense, to be honest. If we went from 4 to 10, what? Where are you going? And then we do basically Castle Bravo said, which maybe I'm on board with now. 20 times 30 times 4 is the volume times 62.4. That's the volume of water that we're moving times the density, which is the force, and then you multiply by the distance, which is 4? For the algebra part of this problem, that's 609,000. We need 673,920. Dude, physics is the worst. Finally, right answer, it's definitely 7. There's a 7 in there, or there's supposed to be one. How's it going, Rowdy? Ugh. All right. I can't do this. I would love to help this person, but this is so shit. Yeah, it's I don't know. I want to do this problem. Like, I feel like I can figure it out, but it's just it's very hard to figure this stuff out. So I'm gonna look for a new one. And the problem is phrase. I don't like how problems phrase it at all. Oh, well, I'm not doing that. Just tell me what the answer are. I'm okay. Putting me in Bitterroot? Not really, no. Have you? I'm just not all that, like, it's fun. Might play it once. But, it's not as fun as when it was, like, a lot smaller. It's still fun in its own way. Like, I sometimes want to play Trinara still, but that's like, I usually want to grind, like, the smaller maps. It's not a small map anymore. Oh, okay, Castle Bravo. I'm sorry if I was misunderstanding you. This in terms of energy, all water egress has some amount of potential energy when it's in that pit. You define 0 at the water level. And in this case, okay, and we get negative potential energy because our y is going up rather than the way I was with the y going down. Altaria? I didn't play that either. I don't know. I've been a little obsessed with Namalsk. I do want to play Alteria. But I don't know, dude, just... I guess the last few weeks has been just like Namalsk with a little bit of Livonia. Yeah, I've seen some people do it on stream, and it seems like they can get a lot of action. It's impure with me, barf, yeah. So, wouldn't getting that first potential energy require an integral? That's why I was saying, that's what I thought you were interpreting, where the first integral for the triangular part does, or the first potential energy for the triangular part requires an integral. The second one doesn't, though. Oh, you're saying, okay, the initial equation would be the integral. Okay. I haven't played much Daisy recently, TBH. Oh, okay, that's fair. You look at the potential energy difference between the two states. That might be an easier way to do it. I bet they're not supposed to do it that way. Just knowing how these classes are often taught. But yeah, no, I thought you meant like still doing it in terms of work rather than I missed the energy part. So I was skimming it too much, I guess, but have you just been doing COD, Rowdy, or what have you been doing then? Or just being in dad, I guess. That'd be a fair answer too. Mostly? Okay. That and dad, yeah. Yeah, that's fair, Castle. Um, oh God, I'm getting a little lazy now. I put a lot of energy, haha, into trying that physics one, and now I'm getting like I just want an easy problem now. It's like planetary orbits, properties along streamline, or all thermodynamics. Oh, okay. Yeah, I forgot a lot of my physics. Man, I don't know if we're gonna have a ton more to do. Oh well. All right. Yeah, I've looked through almost all these. I think I'm just gonna maybe we'll just end things here. I've been doing math for nearly 6 hours, so I probably should give myself a little bit of a break here. Math much, you may not be much. See, I can't even talk right now. You may not be much of a magician, but I sure am an engine nerd. If I didn't butcher that completely, I would have laughed a bit harder. Oh my god. Okay. Let's go raid Pen Center because I believe he's going now. I need to eat. My stomach's been rumbling. I'm gonna end the YouTube stream here. So if you're on YouTube, I appreciate you. I'll be back with another match stream on Tuesday. Oh, Castle Bravo, thanks for the follow. So YouTube, goodbye. Thank you.